Hello there, and welcome to the Sleepy Science Channel. I'm so glad you found your way here tonight. Maybe you've had one of those long days where your body finally stopped, but your mind kept going a little longer than you wanted it to. Or maybe you're the kind of person who'd rather drift off to the strange and quiet corners of the universe than lie there counting sheep. Either way, you're in exactly the right place. There's room here for the tired and the curious, and often they're the very same person. And here's the thing. There's nothing you need to do now. You don't have to follow along. You don't have to remember a single word. You don't even have to stay awake. Just let your body settle into wherever you're resting. Let your breathing slow on its own. Let your thoughts loosen and wander off, the way they do right before sleep. If you drift away in the middle of a sentence, that's not a problem at all. That's the whole point. Tonight, we're going to float out past the familiar sky, past the tidy picture of how galaxies are supposed to behave, and go looking for the ones that quietly break the rules. Not with any hurry. We'll wander from one strange island of stars to the next, the way you might stroll through a garden after dark, pausing wherever something catches the eye. And some of these places really are peculiar. We'll drift toward a galaxy that seems to have misplaced almost all of its invisible mass, as if it simply forgot to bring it along. We'll pass galaxies spinning so fast at their edges that, by every rule we thought we knew, their outer stars should have flung themselves into the dark long ago. There's a galaxy shaped like a perfect ring, with a hole of empty sky at its heart. And there are galaxies out at the very beginning of time that somehow grew up far too quickly, older and heavier than the young universe should have been able to build. Some of what you hear tonight may surprise you, or it may just keep you gentle company as you drift. And just before we begin, if these calm, curious journeys help you unwind or give you a softer way to close out your day, you might consider liking this video and subscribing. It's a small thing, but it helps other tired minds find their way here too, one sleepy soul at a time. Now, if you're ready, let's begin. There's a galaxy out there that seems to have forgotten to bring its dark matter. Almost every galaxy we've ever studied is wrapped in a vast, invisible cocoon of the stuff. Mass we cannot see but can feel through its pull, usually many times heavier than all the stars combined. But a faint, ghostly galaxy called NGC 1052 DF2 appears to be missing nearly all of it. Its stars drift so slowly and so gently that the visible matter alone, just the stars and gas we can actually see, seems to be enough to hold the whole thing together. It's a little like finding a boat that floats with no water beneath it. And so this quiet smudge of light became one of the strangest objects in the sky, simply by lacking the very thing that everything else seems to need. Most galaxies spin so fast at their edges that their outer stars should be flung away. When astronomers first measured how quickly the outskirts of spiral galaxies were turning, the numbers didn't add up. The visible stars and gas simply don't have enough gravity to hold on to those fast-moving edges. By the ordinary rules of motion, those distant stars should be sailing off into empty space, like children let go of a spinning merry-go-round. Instead, they hold their circle, calm and steady, turning as if something unseen has them gently by the hand. That invisible grip is what first hinted at dark matter, a presence we still cannot name, felt everywhere and seen nowhere. Then there's a galaxy made almost entirely of something no telescope has ever shown us. It's called Dragonfly 44. And if you look toward its patch of sky, you'd barely notice it at all. Just the softest wash of light. Yet by the way its few visible stars move, this galaxy appears to be as massive as our entire Milky Way. The difference is that almost all of that mass is dark, invisible, silent. Only a tiny fraction of it shines. Picture a great cathedral built almost entirely of clear glass, so that all you can see is the faint glimmer of the candles inside. It's a reminder that in this universe, what glows may be only the smallest part of what is truly there. One galaxy is a perfect ring, with a core of stars floating alone at its center. Astronomers call it Hoag's object, and it looks almost too tidy to be real. A bright, round hub of older golden stars sits in the middle, and around it, separated by a gap of seemingly empty space, spins a smooth blue ring of younger stars. Nothing obvious connects the two. We're still not entirely sure how a shape like this comes to be, or how it holds itself so gracefully apart. It hangs in the dark, like a stone dropped into still water, frozen at the instant the ripple formed. Some things in the sky seem less like objects and more like a held breath. Some galaxies grew up far faster than the young universe should have allowed. When we look at the most distant galaxies, we're also looking back in time, seeing them as they were when the cosmos was only a few 100 million years old, still practically newborn. The gentle expectation was that we'd find only small, ragged, half-formed things out there. Instead, newer eyes on the sky have found galaxies that already look surprisingly large and mature, heavy with stars, as though they'd skipped their childhood entirely. No one is quite certain how they assembled themselves so quickly. Perhaps, one day, someone drifting off to a quiet voice like this one will grow up to be the person who finally understands why. There's a galaxy whose spiral arms seem to open the wrong way. In almost every spiral we know, the arms trail behind as the galaxy turns, curving backward like the wake behind a boat. But a galaxy known as NGC 4622 appears to have arms that lead instead of follow, reaching forward into the direction of the spin. It may be the memory of an old encounter, a smaller galaxy that drifted too close long ago and left the whole disk turning against its own pattern. It moves like a dancer who has quietly chosen to turn against the music. And it leaves you wondering how many other galaxies carry the fingerprints of visitors long since gone. Some galaxies are as wide as our own, yet so faint they nearly vanish. These are the ultra-diffuse galaxies, and they're a strange breed, spread thin across enormous stretches of space. One of them can be as broad as the entire Milky Way, and still hold perhaps 1,000 times fewer stars, their light smeared out so gently that they hide against the black. For a long time they slipped past us unnoticed, too dim to catch. They drift through their clusters like fog rolling low over a valley, present, but almost impossible to hold in your gaze. It makes you wonder how much of the universe is simply too soft-spoken for us to have heard yet. Right now, that same invisible mass is drifting quietly through the room where you rest. Dark matter isn't only a thing of distant galaxies. Our own Milky Way sits inside an enormous halo of it. And that means it's here too, streaming silently around you and through you as you lie still. It doesn't press on you, doesn't warm you, doesn't make a sound. Countless unseen particles may be passing through your body in this very moment, and through your pillow, and through the floor, without disturbing a single thread. It's a little like resting at the bottom of an ocean you can't feel. Whatever it is, it holds the galaxies together. And tonight, it's cradling you along with them. There's a galaxy where the stars in the center turn one way, while the outer stars turn the other. Counter-rotating galaxies are exactly what they sound like. Two great populations of stars orbiting in opposite directions within the same disk, as though the galaxy could never quite agree with itself. The usual explanation is a merger, gas from another galaxy folding in from the wrong angle long ago, birthing new stars that forever remembered the direction they came in on. So the galaxy carries two histories at once, spinning against itself in perfect, patient silence. It turns like a pair of clocks set gently in opposition, each keeping its own quiet time. And there are galaxies that appear to hold almost no ordinary matter, glowing faintly with the light of stars that seem to have no gas left to make more. In these quiet places, star formation has slowed to the barest whisper, or stopped altogether. Whatever raw material they once had has been used up, or stripped away, or heated until it drifted off, leaving behind only the stars already made, cooling and reddening over the ages. They shine on like the last warmth in a hearth after the fire's gone down. Nothing dramatic remains, only a long, slow settling toward stillness, which in its own way is a kind of peace. Some of the faintest galaxies near us hold so little light that they may hide many more stars than they show. These are the smallest, dimmest companions circling our own galaxy, some so sparse you could count their brighter stars almost by hand. And yet the way even those few stars move suggests a surprising weight of unseen mass keeping them bound. They are among the most dark matter-dominated things we know, tiny pools of gravity with only a scattering of light floating on top. They rest at the edges of the Milky Way, like embers scattered far from the fire, barely glowing, easy to overlook, and still, something we cannot see refuses to let them go. There are galaxies with two hearts, each one a supermassive black hole, slowly circling toward each other. When two galaxies drift together and merge, the enormous black holes at their centers don't collide right away. Instead, they sink toward the middle of the newly joined galaxy and begin a long, wide orbit. Two dark giants turning around a shared center over millions of years. It won't be violent in the way you might picture. It's a slow, elegant approach, a gradual drawing in across unimaginable stretches of time. They move like two lighthouses on distant shores, each aware of the other, patiently closing the distance. And someday, gently, the two will become one. There's a whole class of galaxies that seem to trail glowing tendrils behind them, like something swimming through deep water. We call them jellyfish galaxies, and the name fits, as one of these galaxies falls through the thin, hot gas that fills a great cluster. That gas acts like a soft headwind, combing its material out into long streamers that hang behind it. New stars even light up along those trailing threads, glowing far outside the galaxy's ordinary edge. It drifts through the cluster like a jellyfish pulsing through a dark and silent sea, tendrils shining as it goes. Even in emptiness, it seems, a galaxy can leave a wake. There are galaxies caught in a sudden fever of star birth. Most galaxies make new stars at a slow, steady pace, only a handful each year, the way our own Milky Way quietly does. But a starburst galaxy makes them hundreds of times faster, lighting up whole regions in a single, brilliant surge. Usually something has stirred the pot, a near collision, or a passing neighbor pressing the gas together until it collapses into countless new suns at once. It burns through its own fuel like a candle lit at both ends, blazing bright but never for long. And when the gas finally runs thin, the galaxy settles back into quiet, the fever passing like a warm night, giving way to dawn. Some galaxies fling out twin jets far larger than themselves. From the center, where a supermassive black hole turns slowly, two thin beams of energy stream outward in opposite directions, reaching far beyond the visible galaxy into the dark around it. These jets can stretch for millions of light years, glowing in radio light our eyes could never catch, ballooning into vast, soft lobes at their ends. It sounds violent, and in raw energy it is. Yet from a distance, it looks almost graceful, like a slow fountain rising into the night and drifting back down. The galaxy at the center seems small beside what it quietly breathes out. A rare few galaxies wear a ring around their poles. Instead of a single flat disk, these hold two, one spinning the usual way, and another looping over the top and bottom, crossing the first at a steep angle. The outer ring is thought to be borrowed material, gas and stars pulled from a companion that wandered too close long ago, then caught into an orbit tilted almost sideways. The whole thing turns like a spinning top, wearing a halo, two motions folded gently into one shape. It's a reminder that even something as settled as a galaxy can be quietly rearranged by a passing stranger. Some galaxies stretch out one long glowing tail, like a tadpole drifting through a still pond. This shape usually appears when two galaxies brush past each other, and the gravity of one draws a stream of stars and gas out of the other into a single trailing arm. The bright head holds the main body of the galaxy, while the tail can run for thousands of light years, dotted with clusters of new stars kindled in the disturbance. It drifts through space, trailing that faint ribbon behind it, in no hurry to gather it back. Given enough time, the tail will thin and fade, and the galaxy will grow round and calm once more. There may be galaxies that hold almost no stars at all. We usually think of a galaxy as a place full of light, but some appear to be great clouds of gas and dark matter with scarcely a star to show for it, drifting nearly invisible in the dark. Without enough gas pressing together in just the right way, star formation may never truly begin, leaving a galaxy-sized shape that gives off no light of its own. We only sense them by the way they tug on the things nearby, or by the faint radio hum of their cold gas. They float out there like deep pools with no surface to catch the light. Whether they are common or rare, no telescope finds them easily. Larger galaxies slowly unravel the smaller ones around them. When a little companion galaxy drifts too close, the bigger one's gravity begins to stretch it, pulling its stars into long, thin threads that wind around like ribbons slipping off a spool. These are called stellar streams, faint arcs of stars strung across the sky, the slowly dissolving remains of a galaxy being taken in. Our own Milky Way wears several of these ghostly loops, quiet evidence of meals long past. They circle us like the last trace of something gently coming apart. In time, those stars forget where they came from and simply become part of us. One single galaxy may span more than 4 million light years across. Our Milky Way, wide as it feels, reaches only about 100,000 light years from edge to edge. But the largest galaxies we know dwarf it many times over. These giants sit at the hearts of great clusters, and they grow so vast by swallowing their neighbors one after another over billions of years, each meal adding to their bulk. They hang in space like slow, glowing mountains, built from the pieces of 1,000 smaller homes. To cross one at the speed of light would take longer than complex life has existed on Earth. Some of the brightest galaxies hide nearly all their light behind dust. If you looked with ordinary eyes, they might seem dim, almost shy. But in infrared, they glow brighter than hundreds of normal galaxies put together. Deep inside, behind thick veils of dust, new stars are forming in enormous numbers, and their light warms that dust until it shines softly in wavelengths we cannot see. The dust drinks the brilliance and breathes it back out slowly, like embers wrapped in ash. What looks quiet from the outside can be one of the most alive places in the whole universe. At the center of some distant galaxies sits a point brighter than everything else around it. We call these quasars, and a single one can outshine its entire galaxy of billions of stars. The engine is a supermassive black hole, drawing in a swirling disk of gas that heats to a fierce glow as it spirals inward, releasing light in a final flare before it slips away for good. Most of these blazing hearts lie far off in space, which means far back in time, glimpses of galaxies as they were when the universe was young. They shine across the dark, like distant beacons left burning long ago. The light reaching us tonight began its journey before the sun was born. Now and then, one of those brilliant jets points almost straight toward us. When a galaxy's black hole aims its beam of energy in our direction, we call it a blazar, and from our vantage, it can appear to flicker and flare. Nothing about it is aimed at us on purpose, of course. It is only chance geometry, one thin jet among countless others that happens to line up with our little corner of space. Even so, it feels like catching the gaze of a lighthouse in the moment its beam sweeps by. The light is ancient and indifferent, and yet, for a heartbeat, it seems to be looking our way. There is a family of small galaxies that glow a curious shade of green. They turned up when ordinary people, sorting through galaxy images online, kept noticing tiny round green dots and gave them the playful name green peas. The color comes from oxygen gas lit up by bursts of hot young stars, shining in a particular tint that makes these compact little galaxies stand out. They are small and busy, packed with starbursts, glowing like drops of sea glass scattered across the dark. Some of the strangest galaxies, it turns out, were first noticed by curious eyes with no telescope at all. Some galaxies bend the light of whatever lies behind them. A galaxy can hold so much mass that space itself curves around it, and light passing nearby follows that curve instead of traveling straight. When a more distant galaxy sits directly behind one of these, its light can be smeared into arcs, or even bent into a full glowing ring encircling the closer one. The nearer galaxy becomes a lens, gathering and reshaping a far more ancient light. It's as though the universe left a magnifying glass floating in the dark, quietly showing us things we could never otherwise reach. Our own galaxy is drifting toward a much larger neighbor. Andromeda, the great spiral nearest to us, is moving steadily closer. And in about 4 billion years, the two will meet and slowly merge into one. It won't be a crash in the way the word suggests. The space between stars is so vast that almost nothing will actually collide. Instead, the two great disks will pass through and around each other, drawn into new shapes over long stretches of time. They will fold together like two slow currents, joining into a single wide river. By the time it happens, our sun will be old, and whatever watches from here will see a sky remade in gentle silence. You can actually see that neighbor with your own eyes. On a clear, dark night, far from city lights, Andromeda appears as a faint smudge of glow, the most distant thing most people ever see without a telescope. The light reaching you right now left that galaxy about 2.5 million years ago, long before our kind walked the Earth, and it traveled all that way just to land softly on your eye. So even as you rest tonight, ancient light from another galaxy has already touched you. It asks nothing of you, only that you notice it, or drift off knowing it's quietly there. Some galaxies race through space far faster than their neighbors. Within great clusters, most galaxies drift along together in a loose crowd, but a few tear through at astonishing speeds, thousands of kilometers every second, as if flung by some unseen hand. Often it's the pull of the cluster's combined gravity that whips them onward, or a close pass that slingshots them faster still. They streak through the crowd like a swimmer cutting across a slow tide, and yet, for all that speed, from far enough away they seem hardly to move at all. So grand is the stage they cross. Sometimes two galaxies are caught in the very act of coming together. As their outer stars are drawn into two enormous curving streamers, the pair can look like the long feelers of some great creature reaching across the dark. Along the bridge where the two bodies meet, gas is pressed hard enough to spark a storm of new stars, thousands of bright clusters blooming at once. The whole encounter unfolds over hundreds of millions of years, far too slow for any single night to notice. They merge the way two clouds join in a still sky, edges blurring until you can no longer tell where one ended and the other began. A few spiral galaxies turn with only a single arm. Most spirals wear two or more arms, winding out from the center in a balanced pattern. But now and then, a galaxy shows just one, curling out alone across the disk. It may form when a companion passes close and its gravity draws out one lopsided arm, or when the galaxy's own inner motions fall into an off-center rhythm. It spins there a little uneven, like a pinwheel missing a blade, still turning all the same. There's a quiet charm in something that keeps its grace without perfect symmetry. Many spiral galaxies hold a straight bar of stars laid across their middle. Instead of arms curling right out of the core, these send out a bright, elongated bridge of stars, and only past its ends do the spiral arms begin. That bar is more than a shape. It works like a slow channel, funneling gas inward toward the center, where it can feed new stars, or the black hole waiting there. Our own Milky Way is thought to carry such a bar, quietly guiding material toward its heart. The galaxy turns with a gentle beam of light laid across it, patient as a needle resting on a spinning dial. Some galaxies breathe their own gas out and slowly draw it back again. As clusters of new stars form and the largest among them reach the ends of their lives, they push gas up and out of the disk in great warm fountains. But the galaxy's gravity rarely lets it escape for good, and much of that gas cools, gathers, and rains back down to make new stars in turn. It's a slow cycle of exhale and return, the same material used again and again across the ages. The galaxy keeps its own rain, rising upward and then softly falling back, a weather made of starlight and time. A number of galaxies are wrapped in faint, nested shells of stars. Around a smooth central body, thin arcs of light curve one inside another, like the layers of an onion sliced open, or the rings left spreading in still water. These shells are the settled remains of a smaller galaxy swallowed long ago, its stars sloshing outward and back until they piled into these delicate patterns. They surround the galaxy, like the memory of a ripple long after the stone is sunk. You would need patient eyes and a truly dark sky to catch them, so gently do they glow. Some galaxies bend at their outer edges, warped like the soft brim of a hat. Toward the center, the disk lies flat and even, but far out it tilts and curves, lifting on one side and dipping on the other. Such a warp can come from the pull of a passing galaxy, or from the way the invisible halo of dark matter sits slightly askew around the disk. Our own Milky Way carries a gentle warp of its own out near its rim. It floats there, subtly bent, like a record left a little too long in the sun, still turning smoothly, all the same. Elliptical galaxies hold their stars in a slow, unhurried swarm. Unlike the neat disk of a spiral, an elliptical has no single plane, no arms, no clear direction of turning. Its stars each follow their own long looping path, tilted every which way, private orbits crossing and folding, so the whole galaxy hums, like a soft cloud of bees drifting around an unseen hive. Little fresh gas remains inside, so few new stars are born, and the light leans warm and old and golden. It simply rests there, a glowing ball, rounder in some, gently stretched in others, keeping no particular tune. They are among the quietest shapes the universe knows how to make. Lenticular galaxies sit calmly between two great families. They carry the flat disk of a spiral, yet almost none of its arms, and a swollen center, like an elliptical, as though a spiral had grown still and set its pattern aside. Many of them, we think, truly were spirals once, galaxies that used up or lost their gas and let their arms fade while the disk stayed behind. So they hold the shape of motion without much of the motion itself. Picture a spinning top in the moment just after it slows, its blur resolving into one steady form. They are spirals at rest, keeping the memory of arms they no longer wear. Some spirals wear dozens of short, feathery arms rather than a few long ones. We call these flocculent spirals, from an old word meaning tufted, like scattered wisps of wool. Instead of two grand arms sweeping the whole disk, their light breaks into many small, patchy pieces, each a little thread of new stars flaring and softly fading on its own. No single great wave organizes the whole. The pattern arises here and there, one small segment at a time, across the turning face. It looks like a field lightly dotted with drifting seed heads, never quite forming a line. There's a loose, unhurried beauty in a galaxy that never fully decides on its shape. At the far other end stand the grand design spirals, tracing the whole disk with just two bold arms. Their symmetry is clear even from a great distance. A single density wave moves through the disk, a slow ripple passing through the crowd of stars and gas. And where it goes, it gathers material and lights fresh stars along two clean, sweeping curves. The arms are not solid objects, but patterns, places where the traffic of stars slows and bunches, like a gentle jam sliding around a circular road. The stars drift through. The shape stays. It is order written across a turning world, patient and exact. A few spirals show pale, anemic arms, barely there at all. The spiral pattern exists, yet only faintly, with little of the bright blue sparkle of new stars that lines a lively spiral's arms. Often these galaxies have been slowly stripped of their gas, or have simply spent most of it, leaving arms that trace a shape more than a flame. They are spirals running low on fuel, their design still visible but quietly dimming. Picture a drawing left in the sun until its colors have softly paled. Even fading, the pattern keeps its old elegance. Some galaxies glow lopsided, brighter on one side than the other. Their light is not evenly shared. One flank shines fuller, while the other slips into shadow, as though the whole galaxy leaned gently toward a single shoulder. A close pass by a neighbor can stir this imbalance, tugging stars and gas to gather more thickly on one side. Given time, the disk usually settles back toward evenness on its own. It looks like a lamp whose wick has drifted a little off-center, still warm but uneven in its glow. Even a galaxy, it seems, can rest a touch off balance and keep turning all the same. Two galaxies can stretch a long bridge of stars between them. When a pair drifts close, gravity draws threads of stars and gas out of each. And now and then, these threads meet in the middle and join, linking one bright island to the other across the gap. For a while they hang connected, a faint span of starlight suspended in the dark. It's a slow handshake made of gravity, held open across distances that light itself takes ages to cross. Picture two lanterns on a far shore, and a thin ribbon of glow drawn softly between them. Given enough time, that bridge often becomes the very path along which the two slowly become one. Many galaxies travel through space in bound pairs. Like our own Milky Way and its great neighbor, countless galaxies drift with a single close companion, the two circling a shared center of gravity across billions of years. Sometimes both are grand spirals. Sometimes one is large and one is small. But they move together, tied by a pull neither can shake. Over immense stretches of time, they lean toward each other, their orbits slowly tightening. They are like two dancers who found one another early and never quite let go. Most galaxies, it turns out, keep some kind of company. Small companion galaxies circle the largest ones like moons. Around many big galaxies drift smaller dwarf galaxies, held close by gravity, tracing wide, slow orbits over hundreds of millions of years. Our own Milky Way keeps a modest family of these little ones, faint and quiet, some of them barely more than a loose gathering of stars. They rise and set across the sky of that greater galaxy, soft satellites of light. Picture pale lanterns drifting in patient circles around a brighter one. Even the grandest galaxies, it seems, are rarely truly alone. Some galaxies stand edge-on, cut across by a dark lane of dust. Seen from the side, their disk narrows to a thin, bright line, and threaded through the middle runs a band of shadow where cold dust hides the light behind it. That dust is the raw material of stars still to come, gathered in the flat plain where the galaxy is densest. The well-known Sombrero Galaxy wears such a lane, giving it the look of a wide-brimmed hat laid down in the dark. It hangs there like a silver disk balanced on its edge, a line of light with a soft seam of shadow. Even the darkness in that seam is busy, slowly knitting the stars of tomorrow. Some spirals hold a smooth ring of stars tucked deep inside them. Beyond the bar and the sweeping arms, certain galaxies carry a loop of light close around their center, a ring set within the wider disk. These inner rings form where the galaxy's own gravity gathers gas at special distances, places where the orbits fall into a steady, repeating rhythm and material quietly piles up over time. There the gas settles and lights into a soft circlet of new stars. It looks like a halo drawn gently around the galaxy's heart, glowing inside the larger wheel. Rings within rings, all turning together, keeping a slow and orderly time. The center of some galaxies is shaped like a rounded, boxy swelling, where we might expect a simple round core. A good many barred spirals carry a middle that looks faintly squared off, and viewed edge on it can even show a soft X across its heart. This comes from the bar itself. Over long ages, the stars within it drift up out of the flat plane, thickening the center into a shape like a peanut in its shell. Our own galaxy is thought to carry one of these gently boxed hearts. It sits at the center, like a softly folded knot in the weave. The shape is subtle, written slowly by the patient motion of stars. Great galaxies are wrapped in swarms of ancient star clusters. Far out around the disk, up in the dim halo, hang hundreds or even thousands of tight globes of stars called globular clusters, each holding many thousands of the oldest suns the galaxy owns. They formed early, long before most of the disk had taken shape, and they have circled ever since on wide, slow orbits, high above and below the bright plane. They are like old lanterns hung around a house, keeping their small, steady flames through the night. In them, the galaxy quietly carries the memory of its own beginning. A handful of galaxies drift entirely alone in the great cosmic voids. Most galaxies gather in groups and clusters, held near one another by gravity. But the universe is also laced with immense empty regions, and a rare few float in the middle of that emptiness, with almost nothing nearby. With no neighbors to nudge or disturb them, they evolve slowly and privately, keeping their gas and forming stars at their own gentle pace. Imagine a single house standing in the center of a vast, dark plain, its one small window still softly lit. There is a particular piece in a galaxy that has never once been touched by another. Most galaxies are strung along vast, invisible threads. Zoom far enough out, and the galaxies are not scattered at random. They line up along faint filaments, clustering where those threads cross and leaving great hollows between. This is the cosmic web, shaped over ages by the slow pull of gravity, working on the thin scaffolding of dark matter that runs through all of space. Galaxies slide along these strands across billions of years, drawn toward the denser knots where the big clusters form. It looks like dew collected along the lines of a spider's web at dawn, each droplet a galaxy caught on an unseen thread. The largest pattern we know is also one of the softest to picture. The observable universe may hold as many as 2 trillion galaxies. For a long time, the count sat nearer 200 billion, the number our telescopes could gather one by one. But once astronomers folded in all the faint, small galaxies, too dim to see directly, and reached back toward the crowded early cosmos, the estimate climbed roughly tenfold, up toward 2 trillion. Each of those is a city of hundreds of billions of stars, and most of them we will never photograph one at a time. Picture the grains of sand on every shore of every ocean, and then imagine far more still. The mind cannot truly hold a number like that, and perhaps it was never meant to. A few small galaxies are built of almost untouched ancient gas. The heavier elements, the carbon and oxygen and iron, are forged inside stars and scattered when they die. So a galaxy that has made few stars stays chemically young, its gas nearly as pristine as the early universe left it. A rare handful of nearby dwarf galaxies hold gas this pure, barely enriched at all, as though time had somehow passed them by. They are living windows onto how things looked when the very first stars were lighting. Picture a small pool of the oldest water, clear and still, undisturbed since the very beginning. To gaze at them is to look gently backward through time. The light from these galaxies is reaching you only now, after an enormous journey. Every faint smudge of a distant galaxy is old light, sent out from its stars long before there were oceans on this world, crossing the dark for millions or billions of years to arrive at last. Some of it is passing through the very room where you rest at this moment, the softest rain of ancient starlight, far too faint to feel. It has traveled almost unimaginably far to end its voyage here, quietly against you. When it finally arrives, it simply stops, its long crossing over. You are, in the gentlest possible way, a shore where the light of other galaxies comes to rest. And if one of tonight's galaxies has stayed with you, or if you'd have described it a little differently, leave it in the comments below. I read them in the quiet of each morning, and they often become the seeds of journeys yet to come. For now, let your breathing slow, and let's drift a little deeper. Some galaxies are wrapped in thin rivers of stars. We tend to picture a galaxy's outskirts as a smooth, empty fade. But around many of them, there are long, delicate ribbons of stars looping through the dark. When a small star cluster or a little companion galaxy passes too close to a larger one, the bigger galaxy's gravity gently pulls it apart, and its stars spread out along the path it was already traveling. Over billions of years, those stars stretch into a faint stream that wraps around and around, still tracing the shape of the orbit they once shared. It looks like a ribbon of smoke curling slowly around the flame of a candle. Each stream is the quiet outline of something that used to be, drawn in starlight and left behind. Some small galaxies are born from the leftovers of a collision. Usually, a galaxy gathers itself from the ancient gas of the early universe. But a rare kind comes together much later, from wreckage. When two large galaxies drift close and their gravity begins to mingle, they fling out long tails of gas and stars into the space between them. In the thicker knots of those tails, that scattered material can pull itself together and start to shine, becoming a brand new little galaxy in its own right. It's like sparks thrown from a fire that settle into their own small, steady glows. Even in the middle of something coming undone, something fresh can quietly begin. Some tiny galaxies are only the hearts of larger ones that were peeled away. From a distance, they can look like overgrown star clusters, dense little knots of stars far smaller than they should be. What we're often seeing is the survivor of a long, slow encounter. A modest galaxy wandered too near a giant, and the giant's pull stripped away its outer stars one layer at a time, until nothing was left but the tightly packed core at its center. It's like a stone worn round and smooth after the softer earth around it has washed away. What remains is simply the part that held on longest. Between the galaxies of a great cluster, a faint glow drifts in the dark. We often imagine the space between galaxies as pure emptiness, but in the crowded heart of a cluster, that space quietly shines. As galaxies jostle and pass and pull on one another across the ages, countless stars are torn loose from their homes and set adrift. belonging to no galaxy at all. Spread thin across enormous distances, their combined light forms a dim, even haze that fills the cluster. Right now, trillions of those homeless stars are shining softly, with no one to call their own. They are a kind of shared memory, glowing gently for everyone and no one at once. Some giant galaxies have quietly gathered up everything around them. Galaxies usually live in company, in little groups and families bound loosely together. But now and then, one galaxy grows dominant, and over billions of years it draws in its neighbors, one after another, until only it is left. What remains is a single enormous galaxy glowing alone inside a wide halo of hot gas, surrounded by the empty space where its companions used to be. It's like the last great tree standing in a clearing that was once a whole forest. Its solitude isn't loneliness so much as a long, patient history, gathered inward and held. Some galaxies have fallen into a cluster and come back out again. We tend to think of a galaxy joining a cluster as a one-way arrival, a slow settling in. Yet a galaxy can plunge straight through the dense middle of a cluster, lose much of its gas to the pressure of the crossing, and then swing out the far side on a long, looping path. For a while it drifts far beyond the crowd, before the cluster's pull eases it back again. It's like a swimmer diving beneath a wave and rising, quietly changed on the other side. Some journeys leave their mark on us without ever truly ending. Our own galaxy turns so slowly that a single spin takes hundreds of millions of years. Everything within it is moving quickly, and yet the whole seems perfectly still. The sun carries us along at more than 230 kilometers every second, an astonishing speed. And still the Milky Way is so vast that one complete turn, what astronomers call a galactic year, takes around 230 million years. In all the time you have been alive, you and everything you love have traced only the faintest little arc along that immense circle. It's like the hour hand of a clock, too large for the eye to catch it moving. On the scale of galaxies, patience isn't a virtue. It's simply the way things are. Many galaxies reach far beyond the edge of their own light. The bright, star-filled disk we can see is not really where a galaxy ends. Around and beyond it, there's often a thin, cold layer of hydrogen gas that stretches 2 or 3 times wider than the visible stars, quietly circling, invisible to our eyes, but glowing softly in the low murmur of radio waves. It waits there, a reservoir for stars not yet born. It's like the faint ripples that keep spreading long after a stone has slipped beneath the surface of a pond. A galaxy, it turns out, is always larger and gentler than it first appears. A few galaxies have barely changed since the early universe. Most galaxies grow all their lives, merging, swelling, reshaping themselves again and again. But here and there, we find a compact, densely packed galaxy that made nearly all of its stars in a single early burst, then somehow slipped past every collision that came after. It has simply drifted, untouched, holding stars almost as old as time itself. A small piece of the young cosmos preserved whole. It's like a sealed room where the dust of one ancient morning still hangs in the light. These galaxies are the universe quietly remembering what it was like to be new. Some young galaxies float inside vast clouds of glowing gas. Far out in the early cosmos, astronomers have found enormous clouds of hydrogen, hundreds of thousands of light years across, shining with a soft, cool light of their own. Somewhere within each cloud sits a young galaxy still gathering itself, while the surrounding gas glows as it slowly falls inward and the first stars begin to stir. It's like a single firefly resting at the center of a great, luminous fog. We still aren't certain exactly what makes these clouds shine the way they do. And perhaps someone drifting off to a voice like this one will, in time, be the one who finally understands. Every large galaxy is surrounded by a faint halo of its oldest stars. Beyond the bright spiral arms, in the wide, dim space above and below the disk, there drifts a thin swarm of ancient stars that don't share the neat, orderly spin of the galaxy below. Many of them are the scattered remains of small galaxies swallowed long ago, mingled with the very first stars this galaxy ever made, all of them circling patiently in the outer dark. It's like old photographs kept in the quiet back rooms of a house, rarely visited, but never thrown away. A galaxy carries its entire past softly around itself, wherever it goes. A few black holes drift far from any center, entirely alone. We usually picture a supermassive black hole anchored at the very heart of a galaxy. But that isn't always where they stay. When two galaxies merge and their central black holes are drawn together, the gentle push and pull of the process can nudge one off course, sending it wandering out toward the galaxy's edges, or even loose into the quiet beyond. There's nothing to fear in it, nothing torn apart, only a solitary traveler easing along its own slow path through the dark. It's like a lantern set adrift on a wide, still lake at night. Even the heaviest things in the universe can lose their way home and drift there peacefully. Our whole neighborhood of galaxies is drifting towards something we can barely see. Beyond the ordinary stretching of space, our galaxy and thousands of others are all easing in the same direction, pulled toward a great, hidden gathering of mass that lies partly screened from us behind the crowded band of the Milky Way. Astronomers call it the Great Attractor, and its gentle influence reaches across hundreds of millions of light years. There's nothing sudden about it, nothing to unsettle you, just a slow, shared falling that has been going on far longer than the Earth has existed. It's like leaves resting on a pond, all easing toward the same soft current. We are always, quietly, being carried somewhere. Most galaxies are drifting away from us, and their light stretches as they go. Space itself is slowly expanding, and as it grows, it carries the distant galaxies ever farther from us, like markings on a balloon easing apart as it fills. Along the way, their light is gently stretched toward the red end of the spectrum, reddened and softened by the sheer length of its journey. And the more distant a galaxy is, the faster it appears to recede. It's like a familiar voice, growing lower and quieter as someone walks away down a long, dim hall. Out here, distance is written in color, patiently and without a sound. Some galaxies simply stop, ending in a clean outer edge. We might expect a galaxy's stars to thin out gradually, fading softly into the dark. Yet in certain spirals, the disk of stars comes to a surprisingly definite border and goes no further, perhaps at the radius where the gas grew too thin and calm for any new stars to gather and form. Beyond that line, the shining stops. It's like the last row of a field where the planting quietly ended and the open ground begins. Even the widest, most sprawling things must find their edge somewhere and settle there. The color of a galaxy's light quietly tells us what it's made of. To the eye, a distant galaxy is little more than a soft smudge. But if you gently spread its light into a spectrum, that smudge begins to speak. Each element inside it, the hydrogen and oxygen and iron, leaves its own fine, dark line in the light, like a signature pressed into a page. And from those lines, we can read a galaxy's gases, its age, even the speed at which it drifts. It's like reading the whole life of a tree without ever cutting into it. Light carries far more than it seems to, if you only slow down enough to listen. And if any of these has settled somewhere in your mind tonight, or if there's one you'd tell a little differently in your own words, I'd love to find it waiting in the comments below. I look through them slowly, in the calm of the early hours, and more often than not, a single quiet thought grows into a whole night's wandering. For now, there's nothing more to hold on to. Let your breathing slow. Let the day loosen its grip, and let's ease a little further into the dark together. The arms of a spiral aren't solid things at all, but slow waves passing through it. We tend to picture those bright arms as fixed lanes of stars, sweeping around like the spokes of a wheel. But if they were, they'd wind themselves into a tight knot within just a few turns, since the inner stars circle so much faster than the outer ones. Instead, the arms are density waves, gentle regions where stars and gas crowd a little closer for a while before drifting on through. The way a ripple moves across a field of wheat while each stalk barely stirs. The arm you see tonight is made of different stars than the arm of 1 billion years ago. It's a shape that stays, while everything inside it keeps quietly moving on. Deep in the heart of a galaxy, the innermost stars turn together, almost like a single wheel. Out in the wide disk, each star keeps its own pace, the inner ones hurrying, the outer ones lagging behind. But close to the center, in that crowded inner region, the stars swing around in near lockstep, their speeds rising so smoothly with distance that the whole core rotates as one piece. Astronomers call this solid body rotation because it turns the way a spinning plate does, every part keeping time with every other. It's like the still hub of a carousel, where the horses nearest the middle drift by slow and even. The center holds a kind of agreement that the outer reaches never quite find. Somewhere in every spiral lies a single circle where the stars and the arms keep perfect step. The spiral pattern turns at its own steady pace, slower than the stars near the center and faster than the stars far out. So the inner stars are forever overtaking the arms, passing through them and moving ahead, while the outer stars fall gently behind. But at one special radius, the chorotation circle, a star travels at exactly the speed of the pattern itself, and there it rides along with its arm for age after age, never overtaking, never left behind. It's like walking beside a friend at just their pace, neither of you pulling ahead. In all that turning, there is one quiet ring where nothing ever has to catch up. Some spirals wind their arms tightly, while others let them open wide. If you gathered 100 spiral galaxies and laid them side by side, you'd see the arms curl at every angle, some wrapped close around the core like thread on a spool, others sweeping out in long, lazy curves. The tightness of that winding, what astronomers call the pitch angle, tends to go along with how much mass is gathered in the center and how the galaxy has grown over time. A galaxy with a heavy central swelling often winds its arms more tightly. It's like the difference between a rose still closed and one just beginning to open. Each galaxy settles on its own slow curl, and wears it for billions of years. The shining disk of a spiral is astonishingly thin for how wide it spreads, stretched across 100,000 light years. The disk of a galaxy like ours is only a small fraction of that in thickness, so that compared to its breadth, it is thinner than a single sheet of paper held out at arm's length. Gravity and the gentle ordered turning of the stars press the disk flat over long ages, settling it into a broad, level plane. It's like a round of dough thrown wide and flattening as it spins. For all its enormous reach, a galaxy is mostly a delicate, level film of light, laid out flat across the dark. Above and below that bright, thin disk lies an older, puffier layer of stars. Along with the flat disk, where new stars are still being born, many galaxies carry a second, thicker disk of much older stars, reaching farther above and below the plane and moving a little more loosely. These stars are generally the ancient ones, perhaps stirred up long ago by some passing galaxy, or born already scattered back when the galaxy was young and restless. It's like a soft old blanket laid over a crisp, flat sheet. A galaxy keeps its youth in a thin, bright layer, and its long memory spread gently all around it. Fine magnetic fields thread quietly through the whole body of a galaxy. We rarely think of a galaxy as magnetic, yet running all through its gas and dust is a web of magnetic lines, faint but real, wound loosely along the spiral arms. They're stirred up over long ages by the turning of the disk and the slow churning of gas. And though each single thread is far weaker than the pull of a small toy magnet, together they stretch across the entire galaxy. They help guide where cold gas gathers and where new stars begin to form. It's like the grain running through a piece of wood, invisible until you look closely, yet shaping everything. Even the seemingly empty space between the stars is patterned in ways far too soft for us to feel. Every galaxy is wrapped in a vast, thin halo of hot gas, far larger than the galaxy itself. Beyond the glowing disk, where there seems to be only emptiness, there floats an enormous reservoir of gas, so spread out and so faint that it barely shows at all. This circumgalactic medium can reach hundreds of thousands of light years outward, holding as much ordinary matter as all the stars put together, waiting to fall inward and feed new stars in ages still to come. The same kind of quiet, invisible reservoir surrounds our own galaxy, and its gentle presence stretches out around the small world where you're resting right now. It's like the still air in a room you never notice until a candle flickers. So much of what holds a galaxy together is the part that never shines at all. Galaxies are fed by cool gas that drifts slowly down from the darkness around them. A galaxy can't keep making stars forever from only what it already holds, and yet many have gone on far longer than their own gas should ever have allowed. The answer seems to be a slow, steady rain of cool gas streaming inward along invisible threads from the space between galaxies, quietly refilling the disk without any fuss or flash. This gentle inflow settles onto the outer disk and works its way inward, feeding new generations of stars. It's like a spring that keeps a pond full through the driest summer, unseen beneath the surface. What looks entirely self-sustaining is often being quietly replenished from somewhere far away. Along the arms of many galaxies, new stars light up in evenly spaced knots, like beads on a string. Look closely at a spiral arm, and you'll often find the bright nurseries of newborn stars aren't scattered at random, but strung out at regular intervals, one glowing clump, then a gap, then another. This happens when a long ribbon of gas grows just heavy enough to break into gentle beads. Under its own quiet pull, each bead slowly collapsing into a fresh cluster of stars. It's like dew gathering into evenly spaced drops along a single strand of spiderweb at dawn. Even the making of stars seems to keep a soft and patient rhythm of its own. In the gas of some galaxies, there are tiny beacons of natural microwave light. Here and there, in dense clouds near a galaxy's center, water molecules line up and begin to shine all together in a single pure note of microwave light, a natural cousin of the laser that astronomers call a maser. These water masers are so sharp and steady that we can use them to measure how fast a distant galaxy's inner disk is turning, and even to weigh the black hole hidden at its very heart. It's like a faraway bell rung so clear that its pitch alone tells you the size of the tower it hangs in. Some of the smallest things in the universe carry news of the very largest. At the very center of many galaxies sits a dense little knot of stars, packed impossibly close together. Right at the heart, in a region far smaller than the gap between us and the nearest star, millions of stars can gather into one tight cluster, glowing together as a single soft point of light. These nuclear star clusters are among the densest gatherings of stars found anywhere, and they often keep company with the black hole resting at the galaxy's core. It's like the bright, tight center of a sunflower, every seed pressed snug against the next. In the deepest middle of all that vastness, the stars draw closest of all and hold there, quietly together. A few galaxies hold a small bar of stars nested inside a larger one. Many spirals wear a single straight bar laid across their middle, but in some, if you look right down into the center, there's a second, smaller bar tucked within the first, turning at its own separate pace. This inner bar can help funnel gas even closer to the heart of the galaxy, gently feeding the very center. It's like a small gate set inside a larger one, each swinging on its own quiet hinge. Some galaxies, it seems, keep their secrets folded carefully within other secrets. At the center of some galaxies, the very core turns apart from everything around it. In most galaxies, the inner stars and the outer stars share the same broad sense of motion, all leaning the same way as they swing around. But now and then, we find a small central region spinning to its own tune, sometimes even turning the opposite way from the rest, a heart out of step with its own body. Such a core likely formed when two galaxies merged long ago, and the newcomer stars settled into the middle while keeping their own old motion. It's like a small eddy turning against the drift of a wide, slow river. Deep inside some galaxies, an older memory keeps quietly turning on. Some galaxies send out a jet that appears to move faster than light itself. From a galaxy's core, a thin stream of matter can pour outward at very nearly the speed of light. And when that stream happens to point almost straight toward us, a trick of perspective makes it seem to cross the sky faster than light ever could. Nothing is truly breaking that great cosmic limit, though. It's only that the jet is chasing after its own light as it comes toward us. So the motion looks quickened, the way headlights on a far road can seem to leap forward. There's no violence in it for us, only a beam of light stretched thin across an enormous distance. Sometimes the universe simply plays gently with our sense of speed. A few galaxies still glow with the light of something that has already gone quiet. Now and then, we find a great cloud of gas near a galaxy, shining a strange, deep green. lit not by any nearby star, but by a fierce beam from the galaxy's core, a beam that seems to have faded away tens of thousands of years ago. That light is still traveling outward, still reaching the distant cloud and making it glow, long after its source dimmed, a kind of afterimage written softly across space. It's like the warmth that lingers in a stone long after the sun has set. Why these bright cores fade so suddenly, no one yet fully understands. And perhaps someone drifting through a quiet night like this one will be the one who finally works it out. Some galaxies are quietly making new stars far beyond their bright edge. We'd expect starbirth to stay where the gas is thick, inside the shining disk, and stop where the light gives out. Yet in certain galaxies, faint young stars appear well outside that visible rim, out in the thin outskirts where only the most patient clouds of gas remain. There the gas is so sparse that stars form only rarely, a few here, a few there, spread across enormous stretches of time. It's like a handful of wildflowers blooming far past the last fence, where almost nothing else will grow. Life, even the life of stars, keeps finding the quietest corners to begin in. Some galaxies are caught in the calm just after a great wave of starbirth has ended. Their light tells a curious story, full of the pale glow of young and middle-aged stars, yet almost empty of the fierce blue signs of stars being born right now. It seems that not long ago, in cosmic terms, these galaxies blazed with new stars, and then, rather suddenly, the making stopped, leaving a whole generation behind to slowly cool and settle. Astronomers know them by that gentle mix of recent youth and present quiet. It's like a house the morning after a gathering, still warm, the candles only just gone out. Even in stillness, you can read the echo of a livelier hour. Galaxies. Some galaxies carry a black hole far heavier than they seem to have room for. In most galaxies, the weight of that central black hole keeps a quiet balance with the swirl of stars around it. The bigger the swarm, the bigger the hole. Yet a few galaxies hold a black hole hundreds of times heavier than that gentle rule would ever predict. It may be that these were once far larger galaxies, slowly stripped of their outer stars by a passing neighbor, until only the dense middle and its oversized heart were left behind. It's like finding a great old anchor resting in a shallow pool. Sometimes what remains is only the heaviest part of something that used to be much more. A few spiral galaxies have no central bulge at all. Most spirals thicken toward the middle into a soft, rounded swelling of older stars, a bulge that astronomers long thought every large disk had to grow. But some big graceful spirals are nearly flat all the way in, disk from edge to edge, with no raised center to speak of. That smoothness hints at a calm and undisturbed life, one without the great mergers that usually pile stars up in the core. It's like a still pond that has never once been stirred by a falling stone. A quiet past, it turns out, can leave its own kind of mark, written in what simply isn't there. Some galaxies spin far faster than their size should allow. There seems to be a natural ceiling to how quickly a disk of stars can turn, set by how much mass it holds. And yet a rare handful of giant spirals sweep around at more than 500 kilometers every second, outrunning that expected limit by a wide margin. They are simply enormous, holding many times the mass of our own galaxy, their outer edges racing through the dark far quicker than anything nearby. It's like a great wheel turning so steadily that its rim seems to blur, Even among the largest things we know, a few still manage to move beyond the ordinary. The outer edge of a galaxy turns nearly as quickly as its heart. If a galaxy were only the stars and gas we can see, its distant edges should drift along slowly, the way the farthest planets circle our sun at a lazy crawl compared to the ones close in. But when we measure the true motion out at the rim, the stars there sweep around almost as fast as those near the middle, refusing to slow the way they should. Something unseen must be holding them, a vast weight of dark matter wrapped around the whole disk. It's like the riders at the outer edge of a carousel, keeping perfect pace with those beside the center pole. The visible galaxy, it seems, is only the small, bright core of something far larger and quieter. A few galaxies drive a great wind straight out of their disks. Star formation and the churning heart of a galaxy can pour enormous energy into the gas around them. And now and then, that energy lifts whole rivers of gas up and out, above and below the flat disk. These outflows can rise for thousands of light years into the surrounding dark, carrying away the very material that might have made new stars. There's nothing harsh in it from where we watch, only a slow, glowing exhale spreading outward. It's like steam drifting off a warm lake in the first cool hour of morning. A galaxy, in its own unhurried way, seems to breathe. Some galaxies wear a ring of fiery starbirth around their core. Where a straight bar of stars crosses the middle of a galaxy, it can gently sweep gas inward and gather it at a certain radius, a quiet circle where everything piles up and grows dense. There, ringed neatly around the center, whole necklaces of young stars flicker into being, glowing brighter than the calm middle they surround. It's like a crown of small lights set softly around a lantern. Even in the busy heart of a galaxy, there are patterns that form for reasons of pure balance and hold. A rare galaxy carries 3 bright centers instead of 1. When 2 galaxies merge, we sometimes catch them with 2 glowing cores drifting slowly together. But once in a great while, 3 galaxies find their way into the same embrace. And for a time, the merged shape holds 3 separate hearts, each a dense knot of stars, and perhaps its own heavy black hole. In the long run, they will settle toward a single center. But that settling takes far longer than any of us could watch. There's no collision in the way you might picture, only a slow, patient circling, like 3 leaves turning together in the same gentle pool. Given enough time, even 3 become 1. Some galaxies flare outward at their edges, like an open bowl. We tend to picture a galaxy's disk as evenly thin from center to rim, a flat sheet spread across the dark. But out toward the edges, where the pull of gravity softens, the gas has more room to rise and settle, and the disk quietly puffs up and thickens. Seen from the side, the whole shape widens at the ends, thin in the middle and swelling gently outward. It's like the way a long skirt widens at its hem when it hangs. The farther out you go, the more freely everything drifts, and the shape loosens to match. A few galaxies send out sudden flashes of radio light, again and again. From certain distant galaxies come bursts of radio energy so brief they last only thousandths of a second, yet shine with the strength of a small star's whole output. Most flare only once, but a rare few repeat, flickering out over and over from the same faraway spot. Astronomers suspect the source may be a magnetar, the dense, strongly magnetic remnant of a dead star, though no one is fully certain what makes some of them return. while others fall silent forever. It's like a distant lighthouse whose keeper we have never seen. Perhaps someone drifting through a calm night, much like this one, will be the one who finally learns why they call out more than once. Some small galaxies look far younger than they truly are. Here and there we find little galaxies glowing an intense newborn blue, so bright and fresh they seem to have formed only moments ago in cosmic time. Yet hidden beneath that blue shine sits a quiet population of very old stars, patient and dim. What we're seeing is a sudden fresh burst of starbirth laid over an ancient body, youth painted across great age. It's like a weathered old orchard breaking into new blossom in a single warm spring. Even the oldest places, it seems, can find a way to begin again. Some galaxies simply keep making stars, gently and without pause, for billions of years, rather than blazing up in one great burst and falling quiet. These steady galaxies draw in a slow, reliable trickle of cool gas from the dark around them and turn it into new stars at an even, unhurried rate. Ours is one of them, a calm and constant maker of light. And the very atoms that warmed into life within it are the ones that make up the room around you, and the breath moving softly through you now. It's like a hearth kept low, and even through a long winter night, the light you were born under is still, quietly, being made. An off-center heart beats within a few galaxies. We'd expect the brightest point of a galaxy, its dense nucleus, to sit exactly at the middle. But in some, that heart looks slightly lopsided, brighter on one side than the other, as though the very core were leaning. Often this is a ring of stars circling the central black hole in a stretched, uneven orbit, lingering longer at one end, so that side glows warmer. It's like a candle flame that leans steadily toward one edge of its own soft light. Even a galaxy's center, it turns out, doesn't always rest quite where we'd think to look. Some galaxies blow a thin wind straight from the edge of their black hole. Close around a feeding black hole, where matter spirals inward and heats to a fierce glow, some of that material is pushed back outward instead of falling in, streaming away as a wide, fast wind. It moves at a real fraction of the speed of light, yet spreads outward gently across the galaxy, rather than striking in any single direction. Over long ages, a wind like this can quietly clear away the gas a galaxy would have used to build new stars. It's like a slow breath from a doorway, cool and steady, emptying a warm room by degrees. Even the hungriest hearts, it seems, give something back to the dark. Some tiny galaxies are made almost entirely of dark matter. A few of the smallest galaxies near us hold only a scattering of stars, a mere handful of faint lights, and yet their motions reveal far more hidden mass wrapped around them than their scant glow could ever explain. In these little wisps, the unseen weight outnumbers the visible by 100 to 1 or more, so that the few stars we see are really just faint markers riding within a much larger, invisible body. It's like a few grains of sand tracing the shape of a wind we cannot feel. The smallest galaxies may be the ones most fully made of the thing we still cannot see. Some galaxies are slowly growing from the inside out. A galaxy tends to build its oldest stars first, deep in the crowded middle, and then add younger ones gradually farther and farther out as time goes on. So the heart of such a galaxy holds ancient light, while its outer regions carry stars still relatively fresh, the disk widening outward across the ages like a slow ripple. It's like the rings of an old tree, the center laid down long ago, the newest growth always reaching toward the edge. A galaxy carries its own history outward, one quiet layer at a time. Some galaxies hold a black hole that gives almost no light at all. We often picture the center of a galaxy as a blazing furnace, a black hole tearing brightly at everything that falls near. Yet most of the time, in most galaxies, that central heart is starved and silent, drifting through long stretches with barely a whisper of gas to feed on, and so it stays dark and still. Ours spends most of its life this way, a quiet giant at the center, mostly asleep. It's like a great old bell that hangs unrung through the longest part of the night. Even the mightiest things spend most of their existence resting, waiting, keeping their stillness. I'm working out which part this is in the overall structure. With 12 parts total, the first 30% covers parts 1 to 3, the last 30% is parts 9 to 12, and the middle section, Phase B, spans parts 4-8. Since this is part 7, it falls right in the middle of Phase B, which is where the designed reprise should go. I need to find galaxy facts that fit the breaks the rules of physics theme, but haven't already been covered in my extensive list. I'm scanning through possibilities like double nuclei, ram pressure stripping, polar rings, and ultra-diffuse galaxies. But most of these are already accounted for in what I've written. Let me identify which genuinely new facts I can add to fill out the remaining blocks. Wandering into intermediate mass black holes, globular clusters, metal-poor galaxies, and super spirals with unusually fast rotation. I'm also thinking through ring galaxies from collisions like the cartwheel, warped disks, and galaxies where bars funnel gas inward or maintain counter-rotating gas layers. I've covered tidal tails, shells, dust lanes, and Hoag's object already. Now I'm looking for physics-breaking themes that haven't been explored yet, particularly galaxies that rotate faster than their visible mass should allow, though that's already been addressed with the outer edges spinning nearly as fast as the core. Checking through more exotic phenomena. Stellar streams and filaments are covered. Superluminal jet motion is covered. Gravitational lensing is covered. And ultra-fast black hole winds are covered too. Counter-rotating cores and recoiling black holes from gravitational waves are also already on the list. What stands out as genuinely new is a dark matter ring from a collision, like the one in cluster CL024, where the dark matter itself forms a visible ring structure separate from the visible galaxy. That's a distinct angle I haven't covered yet. I'm also noticing the M-sigma relation could work as a fact. The mass of a central black hole correlates directly with the velocity dispersion of stars in the galaxy's bulge, showing how black holes and galaxies grew together. That's a fundamental relationship worth including. Then there are some more exotic phenomena. Tidal disruption events, where stars get shredded by black holes in repeating flares, and the curious alignment of galaxy spin axes across cosmic filaments, suggesting some kind of coherent rotation pattern on enormous scales. These feel genuinely novel compared to what we've already covered. Looking at what's left to explore, I'm noticing some items that might already be accounted for. Quasar light echoes like Hani's Vorwerp, counter-rotating gas disks, infrared-dominated galaxies, stellar streams as fossil records, and low metallicity systems. But there's something promising emerging. The relationship between black hole mass and galaxy properties, and potentially something about dark matter rings from collisions. Continuing down the list, tidal disruption events and their repeating nature feel genuinely new, as does the idea of coherent angular momentum alignment across cosmic filaments. Some of these others, like galaxies warped by neighbors or fossil groups, seem to overlap with what I've already covered. The concept of stellar halos built from disrupted dwarfs connects to the streams and ancient stellar populations I've mentioned. But the specific angle of new star formation happening within tidal debris might be worth isolating as its own phenomenon. Bars funneling gas inward to feed black holes is interesting mechanically, though I'm worried it risks repeating the bar concept I've already touched on. The rotation curve flatness and counter-rotating populations are definitely covered. Now I'm thinking more broadly about what genuinely breaks expectations. Galaxies that seem impossibly massive or old for their epoch, which ties into the JWST findings I've already noted. I'm also considering gentler structural angles for a deeper exploration. The precession and tilt of galactic disks, gas reservoirs that extend well beyond the visible stars, and how galaxies manage their gas cycling over time. Now I'm thinking through some specific examples to flesh this out. There's the dark matter ring discovered in the collision cluster, CL-RO-24+17e. I could frame that as a ghostly ring of dark matter left behind when galaxies collided. Then there's the M-sigma relation, where a galaxy's central black hole mass correlates with the motion of stars orbiting it, which I could describe as the heart's weight matching the swirl of stars around it. I'm also considering tidal disruption events, where stars get torn apart by the central black hole, creating bright streams. That's a repeating phenomenon worth noting. There's the alignment of galaxy spin axes across cosmic filaments, which is a striking large-scale pattern. I'm thinking about whether to include extended hydrogen disks that reach far beyond visible starlight, though I might already have that covered with earlier points about galaxies extending beyond their bright edges. Superstar clusters forming during galaxy mergers could work as a distinct example, and restarted jets in radio galaxies offer a new angle beyond just jets themselves. I'm also considering S-shaped precession patterns, though that thought cuts off mid-word. Bars interact with dark matter to gradually slow down. Disk ripples are another fascinating case. Our galaxy's disk is actually gently oscillating from a past gravitational encounter, creating phase spirals that we can observe. The plane of satellites problem stands out too. Dwarf galaxies orbiting in an unexpectedly flat plane rather than scattered randomly, which remains genuinely puzzling. I'm narrowing down to about 18 phenomena that best capture the diversity and mystery of galaxy behavior. A galaxy's bar slowing through friction with dark matter, young star clusters igniting during mergers, jets that restart after going quiet, and jets that precess as the black hole wobbles. These are all distinct signatures of galactic dynamics and black hole behavior worth including, though I'm being careful not to duplicate observations already covered. Bulges built from clumps in a galaxy's youth could work as a separate entry from the bar-driven inflows. The Green Valley transition between blue and red galaxies risks overlap with quenching, but reframing it as the slow fading stage itself might distinguish it enough. Misaligned inner and outer disks is a clear structural feature. Halo stars on radial orbits and cool gas raining back from the halo both touch on material I've already covered, so those are candidates to skip. Now I'm narrowing down to about 18 solid, non-overlapping phenomena. Dark matter rings from collisions, black hole mass co-evolving with stellar dynamics, tidal disruption ribbons, aligned spin axes across distances, satellite planes, disk ripples from past encounters, bars slowing against dark matter drag, young star clusters in mergers, restarted jets, precessing jets from a wobbling core. These feel like distinct observables worth highlighting. The bulge itself formed from inward drifting clumps in the galaxy's youth. And I'm noting the green valley transition between young blue and old red populations. Misaligned inner and outer disks. Gas raining back from the halo like precipitation. Halo stars on long plunging orbits and faint hidden gas spirals. I'm also considering radio lobes with hotspots where jets slam into intergalactic gas as a separate phenomenon from jets themselves, and thinking about star formation patterns in certain galaxies. I'm counting up what I have, roughly 15 solid, non-overlapping examples so far, and aiming for around 17 or 18 blocks total to hit the target word count of about 14,000 characters, which works out to roughly 800 characters per block. Now I'm considering a few more candidates. Galaxies, where a passing neighbor triggers a bridge of new stars, and those with radio lobes extending into intergalactic space, with bright hotspots where jets collide with gas. Both feel a bit too close to concepts I've already covered, so I'm skipping them to avoid redundancy. I'm also exploring some fresher angles, like the frame dragging effect around a spinning black hole, which has an interesting physics-bending quality, and galaxies being fed by a thin stream of gas from a tidally disrupted companion galaxy. The most promising new ideas are galaxies whose disks were thicker and more turbulent when young, and have since settled into thinner structures, which is temporally distinct from just having a thick disk layer spatially. There's also the metal enrichment gradient, where the galactic center is richer in heavy elements, and spiral arms that are actually two overlapping patterns rotating at different speeds. That last one feels genuinely novel compared to single grand design spirals. I'm now finalizing my list of 17 blocks, starting with dark matter rings left behind by ancient collisions. Jets traced by precession from the spinning core. I'm listing out 17 distinct galactic phenomena now, from tidal disruptions to misaligned disks to cool gas raining from the halo. Now I need to map these against the narrative structure. With 12 total sections, the first 30% covers parts 1 through 3, and the last 30% should be parts 10 through 12. So there's no reprise needed in this middle section. I'm second guessing whether to include a wonder question coda in part 7. I can have at most one per phase B part, and the satellites in a plane puzzle feels genuinely open, so I'll add it. The humanizing quirk should only appear in the last phase B part, and since part 7 might not be the final one, I'll skip it to be safe. For the second person anchor, I'll weave exactly one into either the ripples block or a quiet as you rest moment. I'm aiming for a warm conversational sleep register in present tense with 5-beat blocks and palette words, matching the poetic literary tone of the excerpt. Contractions feel natural here, so I'll use them softly. All numbers spelled out, no digits. Each block around 800 characters, starting with a headline sentence, and I'll keep the tone calm without leaning too hard into breaking physics framing. That connection shaped them both, each influencing the other across the vast gulf between them. I'm exploring how this coevolution works and what it reveals about the deep structure of galaxies, then moving into the M-sigma relation that quantifies this mysterious pairing. Now I'm turning to tidal disruption, those rare moments when a star's orbit decays and it ventures too close to the black hole, where the immense gravitational gradient stretches it into a luminous stream. 770, neutralized. Good. 4, spin alignment. Some galaxies seem to align their rotational axes across vast cosmic distances, which is strange given that we'd expect each one to spin however chance initially set it. Astronomers are mapping the orientations of galaxies along the same cosmic filaments and finding they tend to lean the same way, like leaves drifting along a slow current all facing the same direction. Even at these enormous scales, there's a subtle order woven through the darkness. 705. Plane of satellites. Wonder question coda. The satellite galaxies orbiting a large galaxy often arrange themselves in a thin plane rather than scattering randomly in all directions, like bees around a hive. Around our own galaxy and others, this unexpected flatness persists, suggesting something about how galaxies form and interact that we're still working to understand. 770. Wonder coda. Good. 6. Disk ringing cycle. Ripples. Second-person anchor. Some galaxies still bear faint ripples from gravitational encounters with passing neighbors long ago. They're otherwise smooth rotating disks subtly disturbed by these ancient interactions. The stars continue rising and falling in slow waves long after the visitor departs, creating delicate spiral patterns that preserve the memory of that brush. And our own galaxy carries such ripples even now, with the ground beneath us riding within that ongoing tremor. It's like the last shimmer on a pond minutes after something touched its surface, a galaxy remembering a gentle touch for an extraordinarily long time. 730. Second-person anchor. The very floor you're resting on rides. Good. 7. Bar slowing. Some galaxies have a central bar of stars that gradually decelerates over time, its once steady rotation around the core slowly losing momentum. When galaxies collide, their gas clouds compress and trigger bursts of star formation in dense clusters. Thousands of young stars igniting together where two calm systems merge, creating a sudden brightness that will endure long after the collision fades. Some galaxies have also restarted their jets after going quiet, with black holes resuming their twin beams of energy after the feeding had slowed and the jets had ceased. The jets precess in a gentle curve when the black hole itself wobbles, like water from a slowly rotating hose tracing an S shape across the sky rather than a straight line. Then there's the clump-fed bulge, where massive clumps of gas in the young universe spiraled inward toward the galactic center over time, building up the central bulge through this inward migration. Isted to follow this hidden rotation, a subtle swirl set into the emptiness itself. It's like the faint, unhurried spiral a slow stir leaves in a cup, drawn into the liquid without ever touching it. Space, we're learning, is less a stage than something that can be quietly turned. 700 years. 13. Thick young disks settling. Many galaxies were once far puffier than they are now, and have slowly settled flat with time. A disk today can be astonishingly thin, its stars gliding along in a smooth, ordered sheet. But early on, that same disk was thick and unsettled, its gas churning up and down as clumps stirred it, and new material rained in. As the ages passed and the churning eased, fresh stars were born into ever calmer, flatter orbits. So a galaxy grew a thin young layer within an older, thicker one. It's like a stirred pond slowly going glassy as the last ripples fade. A galaxy quiets itself gradually, one steadier generation at a time. 660. 14. Misaligned disks. Some galaxies hold two disks tilted against one another. Rather than a single flat wheel of gas and stars all turning in one plane, a galaxy can gather fresh material from a new direction. gas falling in at an angle to what came before. And that newcomer settles into its own tilted disk, turning within the same galaxy on a plane of its own. For a long while, the two lean against each other, an inner sheet and an outer one keeping slightly different tilts, like two record sets spinning on the same spindle, each holding its own gentle slant. 15. Precipitation from halo. Around some galaxies, hot gas high above the disk quietly cools and rains back down. Each large galaxy sits within a vast, thin cloud of warm gas, most of it far too hot and diffuse to ever gather into stars. Yet small regions within that cloud cool and grow heavy, condensing into cooler droplets that drift back down onto the disk, where they may help kindle new stars. The galaxy sheds warmth upward and gathers coolness back in a slow, endless weather of its own, like a fine mist forming near a warm ceiling and settling softly toward the floor. 16. Halo stars on plunging orbits. Some of the oldest stars ride long, plunging paths far out into the dark, falling in close to the galactic heart, and then sailing far out again on stretched, diving orbits that take enormous spans of time to complete. Many were gathered long ago from smaller galaxies that came apart and have kept their wandering ways ever since, like old travelers who never settled into the town's quiet circular streets. 17. Spiral arms. Two patterns. I'm looking at how spiral arms form in different ways. I'm checking the character count across all the blocks I've written so far. Looks like I'm running short of the target by about 1,800 characters. I'll need to add a couple more blocks and expand some existing ones to reach the minimum, aiming for around 14 to 14,500 characters to be safe. For the additional blocks, I'm considering metallicity gradients, where the galactic center is richer in heavy elements than the outer regions, cold gas streams feeding galaxies from the intergalactic medium, and diffuse ionized gas that creates a faint shimmer across the entire disk, each distinct enough from what I've already covered to warrant inclusion. I'm finishing out the explanation of how heavy elements accumulate toward a galaxy's center over time, using the metaphor of well-worked soil in a garden to capture how a galaxy's history is written into its composition from core to edge. Now I'm moving on to a new concept about cold gas streams that feed galaxies from passing companions, which helps replenish the fuel needed for ongoing star formation. The diffuse warm gas between stars creates a soft, continuous glow across the galaxy's disk, some heat radiating from young stars, some rising from the active plane below. So the galaxy shines not just through its stellar pinpricks, but through the luminous space between them. I'm tracking word count across these blocks and should have enough to meet the target. I'm considering whether to add another block or expand existing ones to stay safely above the minimum. I'll add a 21st block to be secure, though I need to avoid duplicating concepts. Galaxies with warped outer edges are already covered, so I'm exploring counter-rotating outer gas disks instead. I've written out a vivid description of nuclear spirals, those delicate miniature spirals deep within galaxy cores that funnel gas toward the black hole, echoing the larger galactic pattern at the smallest scales. That brings me to 21 distinct morphological features across roughly 14,370 words, which feels like a solid stopping point. Now I'm checking the list against what I've already covered to make sure there's no redundancy. Dark matter rings, tidal disruption events, spin alignment, disk ripples, and bar slowing mechanisms are all fresh territory. The plane of satellites is somewhat adjacent to my earlier point about companion galaxies. But the geometric arrangement itself, that sheet-like configuration, is a distinct puzzle worth keeping. Superstar clusters and mergers is a specific phenomenon separate from the general merger and starburst coverage I've already done. Restarted jets, precessing jets with their S-shaped morphology, and clump-fed bulge formation all represent new angles on previously mentioned phenomena. Frame dragging stands alone as entirely new. A galaxy is richer in heavy elements at its heart than out along its edges. When we sample the light from the center and compare it with the faint rim, the inner regions carry more of the weightier atoms, the carbon and oxygen and iron, while the outskirts stay closer to the simple hydrogen and helium the universe began with. The reason is patient repetition. Generation after generation of stars lived and died near the crowded center, each one seeding the gas with a little more of the elements it forged, so the middle was worked over again and again, while the far edges were barely touched. It's a little like a well-tended garden, where the soil nearest the house has been turned so many times it has grown dark and deep. A galaxy, then, keeps its whole history written into its chemistry, from core to quiet edge. Some galaxies are fed by a thin stream of gas drawn from a passing companion. A smaller galaxy drifts too near a larger one, and gravity coaxes a slender ribbon of hydrogen off of it, a bridge of cool material that spills slowly toward the bigger disk. That gas is fuel. It sinks down, settles into the crowded lanes, and eventually cools enough to gather into new stars. So the larger galaxy quietly refills a tank it had been slowly emptying for ages. The stream looks almost like water poured from one cupped hand into another, unhurried, barely visible. It's a gentle reminder that even the great islands of stars share what they have, one slow trickle at a time. Across the whole disk of a galaxy, there drifts a faint, continuous glow of warm gas. Between the bright pinpricks of the stars, the space is not truly empty. It holds a thin haze of hydrogen that has been gently energized, lit from within so softly that it shows only as a diffuse shimmer spread across the plane. Some of that light comes from young stars whose radiation leaks out into the surrounding gas, and some rises from the busy activity below, warming the medium just enough to make it glow on its own. So the galaxy shines not only through its stars, but through the luminous nothing between them, like the soft wash of light that lingers over a city long after its windows have gone dark. There is more brightness in the gaps than we ever tend to notice. Deep inside a galaxy's core, there can be a tiny spiral all its own. Far beneath the great sweeping arms, in the innermost region around the central black hole, the gas sometimes arranges itself into a delicate miniature version of the same pattern, a nuclear spiral only a few hundred light-years wide. These small arms act as channels, gently steering gas inward, letting it lose a little energy and drift closer to the center where the black hole waits. It echoes the larger shape of the galaxy at the smallest scale, a spiral tucked inside a spiral, like the same figure drawn again in the corner of a much bigger drawing. I find that one quietly lovely, the way nature seems content to repeat a good idea at every size it can. The outer gas of some galaxies turns the opposite way from the stars within it. The disk of stars rotates in one steady direction, as disks tend to do, and yet the broad ring of gas farther out is found circling the other way entirely. Such a mismatch cannot grow from a single smooth beginning. Instead, the outer gas was almost certainly gathered later, captured from a neighbor, or drawn in from the surrounding darkness on an orbit that simply happened to run counter to what was already there. Picture two great wheels on the same axle, patiently spinning against each other and never quite touching. Over long ages, the two may slowly blend, but for now, the galaxy holds a quiet disagreement between its center and its edge. A few galaxies were a ring of dark matter left behind by an ancient collision. We cannot see this invisible material directly, but we can trace its gravity by the way it bends the light of more distant galaxies behind it. And in a handful of cases, that bending outlines a great ring far from any bright center. The favored explanation is that two clusters of galaxies once passed through each other, and the dark matter, sloshing outward like ripples in a struck pond, settled into a wide circular shell as things came back to rest. It is a footprint of a crash we never witnessed, drawn in a substance we have never held. Even the unseen, it seems, can be arranged into shapes by a single old encounter. Some black holes tear apart, passing stars, and flare again and again. When a star wanders too close to the giant black hole at a galaxy's center, the pull on its near side becomes so much stronger than on its far side that the star is stretched, then unwound into a long streamer of gas. Part of that gas spirals inward and heats up, releasing a bright flare of light before fading. In certain cases, the star is not destroyed all at once, but grazes past on a long orbit, giving up a little more of itself each time it returns. So the flares repeat on a slow, almost tidal schedule. It is like a comet that brightens each time it swings near. Except here, the visitor is slowly being undone. And yet across the vastness of a galaxy, even this plays out gently. A distant glow rising and settling again. The spin axes of galaxies can line up quietly across enormous distances. Galaxies gather along the great threads of the cosmic web, and when we measure which way many of them turn, we find that their rotation is not scattered at random. Along a given filament, their axes tend to point in related directions, as though they were combed by the same slow flow of matter that assembled them in the first place. The gas and galaxies streamed inward along these cosmic lanes, and they carried a shared sense of spin as they went. Imagine leaves drifting down the same river, each one turning, yet all somehow agreeing on the general way to face. On scales far larger than any single galaxy, there is a faint order written into the turning of things. Some galaxies carry ripples in their disks from an old passing encounter. A companion galaxy sweeps near, and its gravity plucks at the broad disk like a hand set gently against the surface of a drum. Long after the visitor is gone, the disk keeps the memory of that touch as a set of soft vertical waves, rising and falling ever so slightly as they travel outward from where the disturbance began. Our own galaxy is thought to hold such ripples, a slow corrugation moving through its stars. Even now, as you rest, the disk that holds our sun is very gently trembling from something that brushed past it long ago. A motion far too slow and far too vast to ever feel. It is a comfort, in a way, that even a whole galaxy can carry the quiet aftermath of an old meeting. The great bar across a galaxy slowly loses speed against the unseen mass around it. Many spirals hold a straight bridge of stars laid through their middle, and that bar turns as a single pattern. But the invisible halo of dark matter that surrounds the galaxy exerts a subtle, steady drag on it. And over billions of years, the bar is thought to spin down, gradually trading away some of its motion. As it slows, it can grow longer and reshape the orbits of the stars caught within its sway. It's a bit like a spinning top that leans and eases as it winds towards stillness. Though here, the winding takes ages beyond counting. The unseen, it turns out, can lay its hand even on the grandest turning structures and gently ask them to slow. When two galaxies merge, they can ignite clusters of stars far larger than usual. In the calm of a settled galaxy, stars are born in modest gatherings. But when two galaxies fall together, their gas clouds are squeezed and shocked, and the compression is fierce enough to spark enormous knots of new stars all at once. Superstar clusters holding hundreds of thousands of suns bound tightly together. These are among the densest nurseries the universe assembles, forged in the pressure of two great islands becoming one. They shine like sparks struck from flint, brief and brilliant against the merging dark. Some of them may live on for ages, drifting outward as glittering companions long after the union that made them is complete. A galaxy's twin jets can switch off and light up again long afterward. Certain galaxies drive great beams of energy from the black hole at their core, streaming far out into space. Sometimes the central engine grows quiet, and the jets fade, leaving only faint clouds where the old beams once pushed. Then, after a long pause, the black hole is fed once more, and fresh jets ignite straight through the ghosts of the ones before. So we see two generations layered together, new inside old. It is like a fountain that falls still, then quietly begins to flow again through the same worn channels. The pattern tells us these engines do not run forever, but rest and wake, rest and wake. Across spans of time we can hardly hold in mind. Some jets trace a slow, sweeping curve instead of a straight line. When the black hole feeding a jet is itself wobbling, spinning like a top that leans as it turns, the beam it launches sweeps around with it, and the material laid down over time bends into a gentle curve. Seen from afar, the twin jets no longer point straight out, but form a soft, mirrored shape, one arm curling one way and the other curling opposite. The cause is precession, that slow gyration of a tilted spin. Picture the arc a garden hose paints across the grass when it is swayed lazily from side to side. Written across hundreds of thousands of light years, that unhurried wobble leaves behind one of the most graceful shapes a galaxy can draw. The rounded bulge at a galaxy's center may have grown from clumps that sank inward long ago. When galaxies were young, their disks were rough and lumpy, broken into massive knots of gas and stars. Gravity and friction dragged those clumps slowly toward the middle, where they gathered and merged and settled into the smooth central swelling we see today. So the calm, rounded heart of a galaxy may be nothing more than the long-ago debris of its own turbulent youth, patiently collected in one place. It is like sediment drifting down through still water and coming to rest as a single soft mound on the bottom. What looks serene now was assembled, grain by grain, out of an early restlessness. Around a spinning black hole, space itself is slowly dragged along. A massive black hole that turns does more than pull things inward. Its rotation twists the very fabric around it, so that space and everything drifting in it is coaxed to circle in the same direction, whether it wishes to or not. This effect, called frame dragging, means that close to such an object, standing perfectly still is no longer possible, because the ground of space is turning beneath you. It is like a slow whirlpool that carries along even the water that only meant to float. No one has yet mapped this gentle twisting in full detail around a distant giant. And perhaps someone drifting off to a quiet voice like this one will one day be the one who does. The weight of a galaxy's central black hole matches the swirl of stars around it. When we measure how heavy the black hole at a galaxy's heart is, and then measure how briskly the surrounding stars are moving, the two numbers keep close company. Heavier black holes sit among faster swirling stars, lighter ones among calmer motions, and the relationship holds across a great range of galaxies. It hints that the black hole and the bulge of stars grew up together, each shaping the other through the long ages of their shared youth. Picture a stone and the ripples around it, sized so perfectly to one another that you could guess the one from the other alone. Two very different things, it seems, can rise as a single story. Between the young blue galaxies and the old red ones lies a quiet in between. Galaxies busy making stars glow with a cool blue light, while those that have finished settle into a warm, aging red. But there is a middle ground, sometimes called the Green Valley, where galaxies are slowly turning down their star formation, drifting from one state toward the other. They are neither fully alight with new suns, nor entirely at rest, caught in a long, gradual fading. It is like the soft band of dusk between full day and true night, brief compared to either, yet lovely on its own. Every red galaxy we see once crossed that gentle threshold, one unhurried step at a time. Some galaxies once churned with thick, restless disks that have since grown thin and calm. In the early universe, a galaxy's disk of stars and gas was often puffed up and turbulent, stirred by the constant infall of material and the pressure of rapid starbirth. Over billions of years, as the storms of youth eased, the disk had time to settle, its motions cooling and flattening into the slender, orderly plane we recognize in mature spirals today. Our own galaxy holds both records within it, an older thick layer laid down in the tumult, and a younger thin one settled since. It is like a lake that thrashed under a long wind, and then, as the air went still, smoothed itself into glass. The calm we see now was earned slowly out of a much rougher beginning. How quickly a spiral turns quietly reveals how brightly it shines. You might think a galaxy's speed and its glow were separate things, one about motion and the other about light. Yet when astronomers measure how fast the outer edge of a spiral is wheeling around, they can guess with surprising ease how much light the whole galaxy pours into the dark. The reason is that both flow from the same hidden weight. More mass pulls the stars along faster, and it also gathers more of them together to shine. It is like judging the size of a bell from the depth of its ring, the sound and the shape bound quietly to one another. Two measurements, taken worlds apart, that keep arriving at the same soft answer. Elliptical galaxies follow a hidden rule of three. These smooth, rounded galaxies come in a great range of sizes and brightnesses, and at first they seem to scatter every which way, with no order at all, but hold three of their traits together: how wide they spread, how brightly they burn, and how swiftly their stars drift within, and the scatter gently falls away. The three lock into a single tilted sheet, so that knowing any two of them lets you find the third. It hints that these galaxies did not gather by chance, but settled under the same patient rules across the ages. Like three notes that only sound right when played together, they hold a quiet harmony we are still learning to hear. Rounded galaxies gather where the crowd is thickest. Out in the open reaches of space, where galaxies drift far apart from one another, most still wear the graceful arms of spirals. But deep inside the great clusters, where galaxies press close and companions are near on every side, the smooth, armless ellipticals hold sway. The crowding itself seems to be the cause. Repeated brushes with neighbors stir the gas, hush the making of new stars, and slowly smooth a spiral's disk into a featureless glow. It is a little like river stones, jagged when they begin, and rounded by the long company of others. Where galaxies live, it turns out, quietly shapes what they become. Some galaxies are gently starved of the gas they need to shine. A galaxy makes its new stars from a steady supply of cool gas drifting in from the darkness around it, replenished for as long as that supply keeps flowing. But when one falls inward toward a great cluster, that outside stream can be quietly cut off, leaving only the gas already stored within its body. The galaxy keeps forming stars for a while, spending down its reserves until the last of it is used and the lights slowly dim. There is no sudden loss here, only a fading, like a hearth left to burn low once no more wood is carried in. What ends the glow is not violence, but the soft closing of a door. Inside a busy cluster, many small tugs slowly reshape a galaxy. A single close encounter between two galaxies is rare and dramatic. But in a crowded cluster, the passages come again and again, each one a brief, gentle pull as neighbors rush by. No single one of them does very much. Together, though, across billions of years, they heat a small spiral's orderly disk, puffing it up and gradually unwinding its arms. Astronomers name this steady wearing away harassment, even though it unfolds far too slowly and softly to feel like any kind of harm. It is like a coastline shaped not by one great storm, but by the endless small returning of the tide. Patience, even from gravity, leaves its mark. A few galaxies crowd into tight little knots called compact groups. Most galaxies keep a respectful distance from one another, drifting apart across the wide dark. But here a handful gather so close that they seem almost to touch, bound together in a small and intimate circle. Their shared gravity draws long threads of stars between them and stirs quiet bursts of new light where their gas gently meets. In time, many such groups will settle inward and become a single larger galaxy, their separate shapes folding into one. Like a small circle of friends leaning in around a low table, they share a nearness the wider universe rarely allows. And when the leaning becomes an embrace, several stories quietly become one. The largest galaxies finished making their stars first. It would seem natural for the biggest things to take the longest, growing slowly and steadily toward their final size. Yet the heaviest galaxies formed most of their stars early and quickly, back in the young universe, and then fell quiet, while smaller galaxies have gone on making new suns at a gentle pace ever since. Astronomers call this reversal downsizing, and its finer details still softly puzzle us. It is as though the great cathedrals were all raised in the first years, and the small cottages are being built even now. The universe, it seems, does its boldest work while it is still young. Long ago, the whole universe made stars far faster than it does today. If you could somehow watch the entire sky across cosmic time, you would see a great rise and fall in the birth of stars. Billions of years back, in a stretch astronomers call cosmic noon, galaxies blazed with new suns at a rate many times higher than the one we see around us now. Since then, the pace has slowly eased, as the cool gas that feeds starburst grows scarcer and harder to gather in. It is like a long afternoon settling gently toward evening, the brightest hours already behind us. We live in the calm, later light of a universe quietly winding down. Some central swellings were built slowly by the galaxy's own disk. Many galaxies carry a rounded mound of stars at their very heart, and often it was assembled long ago in a rush of the early years. But others hold a gentler kind of center, one the disk itself grew over ages, by drawing gas patiently inward toward the middle. These softer bulges still turn along with the disk, keeping its flattened, orderly motion, rather than swarming every which way. Astronomers call them pseudo-bulges, the quiet cousins of the older, rounder kind. It is like a slow drift of sand gathering at the still center of a stream. Not every heart, it seems, is forged in haste. Hot gas sometimes rises and escapes a galaxy's disk through great chimneys. Where many stars are born and later fade together, their combined winds carve out vast bubbles of hot gas within the disk. When such a bubble swells large enough, it can break clean through the disk's thin face, opening a wide column that lets the warm gas pour upward into the halo above. Astronomers borrowed the homely word chimney for these openings in the star-filled plain. Like smoke finding its way up a flue on a still night, the galaxy quietly lets its hottest breath rise into the dark. Even a disk of stars, it seems, needs a way to let the heat move on. When two galaxies merge, their stars settle into a smooth, new shape. As the pair folds together, the gravity of the joining mass shifts and heaves for a time, and every single star feels a changing pull beneath it. Rather than tearing anything apart, this shifting gently reshuffles the orbits until the stars forget their old paths and gather into one rounded, unhurried swarm. Astronomers gave the process the stern-sounding name violent relaxation, though what it truly brings is a lasting calm. It is like two streams pouring into a single still pool, their separate currents dissolving into one quiet surface. Out of the mingling comes not ruin, but a smoother and more peaceful whole. The most distant galaxies reach us as they were in their infancy. Their light has traveled so unimaginably far that it left them when the universe itself was very young, long before the Earth or the Sun had come to be. So when that ancient glow finally arrives, we are not seeing those galaxies as they are now, but as they were in their first tender age, forever young in our eyes. And that faint, patient light is settling into the room around you even now, having crossed almost the whole history of time simply to do it. It is like receiving a letter written so long ago that its writer has utterly changed. To look outward, here, is always to look quietly into the past. Galaxies were first set spinning by the gentle pull of their neighbors. A galaxy's slow rotation feels like something it must have always carried, as if it were born already turning. But in the young universe, before galaxies had fully gathered, each growing cloud of matter was tugged a little unevenly by all the others around it. Those soft, off-center pulls gave each cloud a faint twist, and as the cloud drew inward and shrank, that early twist wound up into the steady spin we see today. It is like a skater drawing in her arms, a small beginning turn becoming a lasting one. Every galaxy's rotation, then, is a quiet keepsake of the neighbors it once had. Some galaxies are known to us only as shadows against a brighter light behind. Far across the universe, the steady glow of a distant beacon sometimes passes straight through an unseen cloud of gas on its long way to us. That gas, the raw material of a galaxy far too faint to see on its own, drinks in certain colors from the light behind it, leaving dark gaps we can gently read. From those gaps, we learn what the hidden galaxy is made of, its makeup laid bare, though we never once see it shine. It is like knowing a window pane only by the way it softly dims the lamp beyond. Even what stays dark, it turns out, can leave a clear and lasting trace. Many galaxies hold far fewer ordinary atoms than the recipe would predict. When we tally the visible matter in a galaxy, all the stars and the gas we can see, it comes up short against the amount the young universe should have handed it. The missing atoms are not truly gone, though. Much of that plain matter lingers, thin and warm and nearly invisible, spread through the vast halo wrapped around each galaxy and the wider web that stretches between them. It is like a house that seems half empty until you notice the very air is full. Most of a galaxy's ordinary substance, it seems, simply drifts quietly out of sight. Neighboring galaxies tend to grow quiet together. When astronomers find a galaxy that has stopped making new stars, they often notice that its nearest companions have hushed as well, as if the calm were somehow shared across the empty space between them. The same holds for the lively ones, which tend to keep busy neighbors close at hand. Some of this comes from a shared surrounding, and some from the gentle sway galaxies hold over the gas around them. Like houses along one street settling into darkness near the same hour, they seem to keep a loose, unspoken rhythm. Even across the great distances, galaxies appear to feel one another's mood. Some galaxies grow quiet long before they ever reach the great clusters. We often picture a galaxy falling straight from open space into a dense cluster, where it is finally stilled among the crowd. But many first spend long ages in smaller groups along the way, and in that gentler company, they already begin to lose their gas and slow their making of stars. By the time they arrive among the thousands, much of their quieting has already been done. It is like a traveler who grows tired on the country roads long before ever reaching the crowded city gates. The great change, so often, is only the last small step of a much longer, slower journey. The small galaxies orbiting a great one often circle within a single thin plane. We might expect a galaxy's little companions to swarm around it from every direction at once, like bees about a hive. Yet around several large galaxies, including our own, many of these satellites are found lying and moving within one broad, flattened disk, as though arranged by some quiet and unseen hand. Why they should settle into such a plane, rather than scattering freely through the dark, is still gently debated among those who study them. It is like finding a scattering of leaves that have somehow all come to rest upon the same still surface. The order hidden within it is one we have not yet fully explained. Light echoes can travel across a galaxy long after the star that made them has gone dark. When a distant star flares brightly, its sudden flash of energy travels out in all directions through the cold dark of space. Some of this light travels straight toward our telescopes, but some of it hits distant clouds of cosmic dust first and bounces off at an angle. This reflected light takes a longer, winding path to reach our eyes, arriving years or even centuries after the main flash has faded away. It's like an acoustic echo bouncing off the walls of a silent canyon, returning as a soft whisper long after the first shout has died down. In this way, we can watch the gentle reflection of ancient stellar flares that occurred long before we ever built instruments to look, a quiet reminder that the past still travels through the dark. Some dwarf galaxies hold almost no dust at all within their boundaries. These tiny, faint collections of stars appear completely clean, lacking the thick clouds of carbon and silicon that usually drift between the suns. Without this dust to shield the cold gas, new stars struggle to form, leaving the existing stars to age in quiet isolation. The light from these systems is exceptionally pure, unfiltered by the dark lanes that warp the shapes of larger spirals. It's like a clean pane of glass sitting in a darkened room, letting the soft glow of distant candles pass through without a single shadow. They remain as pristine relics of a simpler time, untouched by the cycles of growth and change, drifting quietly in their own private corners of the cosmos. Ghostly streams of stars wrap around many large galaxies, like delicate threads. These stellar streams are the remains of smaller galaxies that ventured too close and were slowly pulled apart by the larger galaxy's gravity. Over billions of years, the stars from the disrupted companion are stretched out into long, elegant loops that circle the main galaxy for hundreds of thousands of light years. As you lie resting in the quiet of your room, similar invisible streams of ancient stars are drifting silently, high above your head, marking the slow paths of long-lost worlds. It's like a long ribbon of silk caught in a gentle breeze, winding slowly around a spinning top. The past is never truly lost in these quiet spaces, but is simply rewritten into a softer, wider shape that we are only now beginning to map. Cold molecular clouds sit in silent expectation before the first stars begin to shine. These dark nurseries are filled with cold hydrogen gas, kept at temperatures just a few degrees above absolute zero, the lowest temperature possible in the universe. At these low temperatures, the gas is heavy and still, slowly settling under its own weight without the restless energy that heat provides. There are no bright stars inside to light the gas, leaving these regions completely dark and silent for millions of years. It's like a quiet forest in the hours before the dawn, waiting for the first touch of light to wake the sleeping trees. They are reservoirs of pure potential, holding the raw material of future worlds in perfect, icy stillness until the time is right. The first generation of stars lit up the young universe in a slow dawn. Before these stars arrived, the universe was a dark and featureless place, filled only with a cool mist of hydrogen and helium gas. Slowly, over hundreds of millions of years, gravity drew this gas together into the very first dense clumps, until the pressure at their hearts grew great enough to spark the first nuclear fire. These giant stars were incredibly bright and pure, shining with a light that had never existed before in the dark cosmos. It's like the first match struck in a vast, pitch-black hall, casting long shadows across the empty space. That ancient morning set the pattern for everything that would follow, transforming the dark void into a garden of light that we can still detect in the oldest corners of the sky. Galaxies lose their outer layers of gas when they fall into the crowded center of a cluster. As a single galaxy plunges through the hot, invisible gas that fills the space between cluster members, it experiences a gentle headwind. This wind is strong enough to push the loose, cool gas right out of the galaxy's outer edges, leaving its stars behind while stripping away its fuel for future generations. The process is remarkably gentle, removing the gas without disturbing the orbits of the stars themselves, leaving the galaxy's shape intact. It's like a gust of wind lifting the dry leaves from a tree in autumn, leaving the branches bare but unbroken. The galaxy continues on its path, lighter and quieter than it was before, drifting through the crowd. Faint planetary nebulae drift through the quiet spaces between stars like glowing embers. These delicate shells of gas are cast off by stars, like our own sun, as they reach the very end of their long lives. The dying star gently expels its outer layers into the surrounding space, creating an expanding bubble of gas that is lit up by the hot core left behind. These structures last for only a few tens of thousands of years, a mere blink in the lifetime of a galaxy, before they fade into the general background. It's like a single soap bubble catching the light of a lamp before it quietly dissolves into the air. They are the soft, colorful signatures of a star's peaceful farewell, leaving behind a quiet, white dwarf to cool in the dark. The magnetic field of a galaxy gently aligns the dust grains drifting through its space. Although these magnetic fields are incredibly weak, thousands of times weaker than the one that guides a simple compass on Earth, they exert a persistent influence over the cosmic dust. Over vast spans of time, the tiny, elongated grains of dust rotate until their long axes lie perpendicular to the magnetic lines. This alignment causes the light passing through the dust to become polarized, allowing astronomers to map the shape of the magnetic field by looking at the angle of the light. It's like a light breeze turning every vein on a hillside to face the same direction. A quiet order is maintained across the darkness, guided by forces we cannot see but can trace through the light. Sibling stars born in the same cluster gradually drift apart to wander the galaxy alone. When a new cluster of stars is born from a single gas cloud, the stars start out close together, bound by their shared gravity. Over hundreds of millions of years, the gravitational pulls of passing clouds and other stars gently nudge them out of their original orbits. One by one, the stars slip away from the group, spreading out across the wider galactic disk until they can no longer be identified as family. It's like a handful of seeds carried away by a summer wind, taking root in distant corners of the field. Each star goes on to live its own quiet life, far from the place where it first caught light, carrying only its chemical signature as a memory. Vast pools of cool gas gather at the intersections of the cosmic web. The cosmic web is a network of thin filaments made of dark matter and gas that stretches across the entire observable universe. Where these filaments cross, gravity is strongest, drawing in gas from the surrounding emptiness to form deep, quiet reservoirs of material. This cool gas slowly drains down into the centers of these valleys, where it can eventually be used to build new generations of galaxies. It's like rainwater pooling in the hollows of a long, uneven road after a gentle shower. The universe holds its resources in these quiet catchments, waiting for the slow turn of time to bring them to life under the pull of gravity. Red spiral galaxies show that a galaxy can stop making stars without losing its shape. For a long time, it was believed that spiral galaxies were always blue and active, while old, quiet galaxies were always rounded and red. Recently, however, astronomers have found spirals that are completely red and silent, containing only old stars and holding almost no gas to make new ones. These systems have somehow managed to shut down their star birth, while keeping their delicate, winding arms perfectly intact. It's like a clock that has stopped ticking but remains beautiful, its hands frozen in a graceful curve. They prove that a quiet life does not require us to abandon the elegant structures we built in our youth, showing us a peaceful way to age. The light from distant stars is softly polarized as it travels through galactic dust. When starlight encounters the tiny grains of carbon and silicate that drift in the space between stars, it does not pass through unchanged. The dust grains block some directions of the light waves more than others, organizing the chaotic vibrations into a single, uniform direction. By studying this polarized light, we can trace the invisible paths of the magnetic fields that run through the galaxy's disk. It's like looking at the world through polarized sunglasses, which reveal the hidden glares and reflections that are usually lost in the bright day. The dust, though it darkens the sky, helps to reveal the subtle structures that hold the galaxy together in a quiet embrace. Some galaxies are so diffuse that their stars are separated by immense stretches of empty space. These ultra-diffuse galaxies can be as wide as our own Milky Way, but they hold only a tiny fraction of the stars, scattered so thinly that the galaxy is nearly transparent. If you were to stand on a planet orbiting a star in one of these systems, the night sky would look almost completely black, with only a few faint points of light visible in the distance. It's like standing in the middle of a dark field at night, with only a single farmhouse light visible on the far horizon. They exist as quiet, airy structures, holding their vast space with a gentle and minimalist grace, almost blending into the empty universe around them. White dwarf stars in the outer halo of a galaxy slowly cool over trillions of years. When a star like our Sun has exhausted all its fuel, it leaves behind a dense, hot core about the size of the Earth. Because this core has no way to generate new heat, it can only radiate its remaining warmth into the cold surrounding space, a process that takes longer than the current age of the universe. Over immense spans of time, these white dwarfs will fade from white to yellow, then to red, and finally to a cold, dark black. It's like a glowing coal taken from the fireplace, sitting on the hearth and slowly losing its light until it is cool to the touch. They are the patient timepieces of the cosmos, marking the slow passing of the long night with quiet constancy. Our local group of galaxies is held together by gravity, while the rest of the universe expands away. While the vast majority of galaxies are moving apart as space itself stretches, our small neighborhood remains bound in a quiet embrace. The gravity of the Milky Way, Andromeda, and dozens of smaller companion galaxies is strong enough to resist the general expansion, keeping us close together through the cosmic ages. In the far future, all the distant galaxies will slip beyond our horizon, leaving only our local group visible in the night sky. It's like a small group of friends holding hands on a moving platform, staying together while the crowd around them drifts away. In a changing universe, some connections remain quiet, steady, and unbroken. A thin, warm fog of atoms fills the vast empty space between the galaxies. This intergalactic medium is incredibly sparse, holding only a few atoms in every cubic meter of space, far emptier than any vacuum we can create on Earth. Yet because the space between galaxies is so immense, this thin fog actually contains most of the ordinary matter in the universe. It is warmed by the light of distant quasars and stars, keeping it from freezing but leaving it too thin to collapse into new stars. It's like a quiet morning mist that hangs over a wide valley, invisible from a distance, but filling the entire space with a soft, damp presence. The universe is never truly empty, even in its most silent and lonely depths. Galactic disks grow steadily thinner and more orderly as they age. When galaxies are young, they are wild and turbulent places, with gas and stars moving in chaotic, highly tilted orbits that create a thick, puffy shape. Over billions of years, the constant collisions between gas clouds slowly cancel out these random motions, forcing the material to settle into a single, flat plane where everything turns in the same direction. The stars that form from this settled gas inherit this orderly motion, creating the thin, graceful disks we see in mature spirals today. It's like a stormy sea that gradually settles into a glass-like calm after the wind has died down. The passage of time brings a quiet order to the most restless of systems, smoothing away the rough edges of youth. The cosmic microwave background radiation fills the entire universe with a soft, uniform hum. This light is the oldest in existence, left over from the hot, dense state of the universe shortly after its birth. As the universe expanded, this light stretched out to become microwaves, cooling down to just under 3 degrees above absolute zero. It is present in every direction we look, a gentle background glow that bathes every galaxy in a quiet, thermal warmth. It's like the faint, warm air that lingers in a bakery long after the ovens have been turned off for the evening. No matter how dark the space between galaxies seems, this ancient light is always there, filling the quiet voids. I'm working through the structure for part 11, which is the lullaby register phase, the final stretch before the conclusion. This section needs to be more restrained than earlier parts. No calls to action, no reprises, no rhetorical questions. Just one moment where I address the reader directly. I'll open with a strong headline and close with a coda, keeping the tone intimate and reflective without any farewell gestures. The length should land somewhere between 13,500 and 15,250 characters, distributed across roughly 18 blocks, with each block running shorter than the earlier phases. For the content itself, I'm gathering fresh cosmic facts that haven't appeared yet. Things like how galaxies redden as they age, the way the night sky will darken as expansion accelerates, the eventual merger of the local group into a single elliptical galaxy, and the long persistence of red dwarfs burning for trillions of years. These details should feel gentle and descending, moving toward that final bridge between the cosmic and the personal that Part 12 will complete. I'm narrowing down which facts are genuinely distinct from what's already covered. Gas depletion as an intrinsic process is separate from the cluster stripping angle. The merger of the local group into Milky Way is a solid future endpoint. The reddening of galaxies as they age is tricky since color shifts were touched on, but the aging process itself might work as a distinct angle. Brown dwarfs and red dwarfs as the longest-lived stellar remnants are worth including. The phrase "red and dead" captures the final state nicely. Now I'm thinking through additional far future facts to round out the arc. Stellar remnants cooling over eons, rogue planets drifting through the void, the Milky Way's solitary future sky, and the sun's own trajectory. I'm aiming for around 18 blocks of roughly 780 characters each, starting with the local group's eventual merger into a single galaxy. Red dwarfs will dominate the timeline, burning steadily for trillions of years after everything else has faded. Brown dwarfs drift as failed stars through the galactic dark, Galaxies exhaust their gas reserves and stop birthing new stars. The vast gulfs between stars dwarf the stars themselves. Rogue planets wander those empty spaces between suns. Galaxies shift toward red as their massive blue stars die first, while smaller ones persist. Even after star formation ceases, galaxies continue their slow rotation. Eventually, stellar remnants, white dwarfs, and neutron stars will outnumber the living stars that remain. I need to be careful not to repeat what I've already covered. Let me refine my list of distinct facts. The local group merger in the far future is separate from just drifting toward Andromeda. And red dwarfs burning for trillions of years is a key longevity point. Brown dwarfs drifting between stars is another angle on stellar remnants and the long-term fate of the universe. Ains of sand on a beach. That comparison captures the sheer scale nicely. I'm reviewing what I've already covered and skipping some redundant points about metallicity, distant galaxies, and stellar separation. Then considering alternatives for the remaining slots. Neutron stars spinning down over cosmic timescales feels distinct enough to include. Let me lock in a final set of around 15 blocks that capture the key moments. The merger of the local group, the long reign of red dwarfs and brown dwarfs, gas depletion, the vast emptiness between stars, rogue planets, the aging of light, the galaxy still rotating after its last star dies, remnants vastly outnumbering living stars, the sun's slow orbit as an anchor point, the realization that most of the galaxy's existence lies ahead, neutron stars gradually slowing, the awe of comparing grains of sand to stars, galaxies dimming gently, and the ultimate calm of the far future. I'm roughly calculating whether this fits the target scope. I'm settling on nucleosynthesis and dying stars as block 16, then adding the spiral pattern fading as gas depletes for 17, and closing with a galaxy settling into calm after its last stars fade. That final image bridges nicely toward part 12. Aiming for around 17 blocks total to hit the word count target. Now I'm ready to write, keeping numbers spelled out and using 5 beats per block with phase C slightly softer. Starting with the local group merger as the opening image. I'm finishing the first block, the galaxies merging into one calm island of light, around 730 words. Now moving into red dwarfs, the smallest and most abundant stars that burn so slowly they'll outlast nearly everything else in the universe, their fuel lasting trillions of years. Ned down almost to nothing, there's something quietly dignified about these in-between objects, neither fully star nor planet, just drifting through the darkness on their own terms. Galaxies gradually exhaust their gas reserves as new stars form, since most of that material gets locked away and rarely returns. Over time, a galaxy that can't replenish from outside begins to starve, its star-forming clouds growing thinner until the bright new births slow to almost nothing, like a fire that's simply run out of fuel rather than burned out from any catastrophe. The vast emptiness between stars is almost impossible to grasp. Galaxies look dense from a distance, but each star actually floats in an enormous void. If our sun were a grain of sand, the nearest star would be another grain kilometers away, with nothing but darkness between them. This is why even when galaxies collide head-on, their stars almost never touch, passing through each other like two clouds of insects crossing at dusk. And beyond the galaxies themselves, rogue planets wander the dark between the stars, untethered to any sun. The phrasing, "some think," appropriately hedges the claim about rogue planets being more numerous than stars, so it works fine for this section. Now I'm looking at how galaxies change color as they age. The brightest blue stars burn out quickly, while cooler red ones persist, so older galaxies gradually shift from blue toward red as their stellar population evolves. This color shift is essentially a visual record of a galaxy's history, written across its light. The passage then moves into describing how galaxies continue rotating long after they stop forming new stars. Eighter and greater numbers, until one distant day, the galaxy holds more embers than flames. They will drift along the same old orbits, dark and faithful, like lamps carried home after a long evening. What remains, in the end, is not emptiness, but the resting shapes of everything that once shone. 570, Block 10. Sun orbit, anchor. The sun carries us on a long, slow circle around the galaxy. Right now, as you lie still, the ground beneath you is not still at all. The sun and all its planets are sweeping through the galaxy at more than 230 kilometers every second, tracing a vast circle so wide that a single wave. I'm continuing with the passage about our solar system's motion through the galaxy. The vast orbital journey that takes hundreds of millions of years to complete, a movement so gradual and encompassing that we experience it as stillness. I'm also checking that the specific velocity figure aligns with earlier references and the config example, which it does, so I'll keep it. Now moving into the next section about how most of a galaxy's life still stretches ahead of it. Neutron stars gradually slow their spin over millions of years, sweeping the darkness with faint lighthouse-like beams. Then I'm moving to the comparison of stars and sand. A single galaxy contains more stars than grains of sand on any shore, a number so vast it's nearly incomprehensible. And that's just one among trillions of galaxies. I'm finishing that sentence about the immensity of stars, then moving on to the galaxy section. I need to be careful not to restate the earlier fact about star formation rates, so I'm reframing this part to focus on the far future dimming of galaxies as their gas depletes and their brightest stars fade, rather than revisiting how quickly they formed in the past. Now I'm noticing there's overlap with an earlier block about color aging and reddening, so I should probably cut this section entirely to avoid redundancy. I'm counting through the blocks to see where I stand and thinking about how to transition toward the cosmic personal bridge that comes in Part 12. I'm adding up the character counts across all the blocks to get a total, though I realize my estimates were rough and the actual count is probably higher. Let me verify by checking one of the blocks directly to see if my character estimates are accurate. Think I need to expand the piece significantly to hit the target length. I'm brainstorming additional galaxy facts that fit the contemplative, far future tone. Things like nucleosynthesis in dying stars, ongoing planet formation, and the eventual dominance of black holes as the universe ages. Some of these overlap with what I've already covered, so I'm filtering for truly distinct concepts that haven't been explored yet. The neutral hydrogen radio signature is worth including as a distinct element. I'm considering 3 new blocks to add: the forging of heavy elements in dying stars, the view of Andromeda growing across our sky during the merger, and that faint radio glow from cold hydrogen permeating galaxies. Now I'm working through some additional candidates: bright stars dominating a galaxy's light output, the possibility of black holes as the final lights in the far future, and how the oldest stars concentrate toward the galactic center. Some of these overlap with what I've already covered, so I need to be selective about what's truly distinct enough to include. I'm also thinking about the temporal scale beyond the stelliferous era itself, naming that age of starlight as a distinct chapter. Then what comes after is a long twilight of cooling remnants. To reach my target count of around 23 blocks, I need to add roughly 9 more full entries at 600 to 700 words each, which should bring the total to about 14,000 words. For the final ordering in this temporal descent phase, I'm mapping out the sequence. The local group merging into one galaxy, the era of red dwarfs lasting trillions of years, brown dwarfs, gas depletion, the vast emptiness between stars, and rogue planets drifting alone. A long, gentle twilight of cooling remnants. When the last new stars fade, the galaxy settles into deep calm. I'm estimating around 21 blocks total, which should give me roughly 12,600 words if I flesh each one out generously. Let me verify there's no overlap with what I've already covered. The heaviest elements forged in dying stars is distinct, and the future view of Andromeda growing in our sky is different enough from the current visibility angle, though I should be careful about redundancy there. The far future radio glow from cold hydrogen, the handful of remaining bright stars, the stelliferous era as a named epoch, and the black hole's final lights are all distinct concepts. There's a slight overlap between the twilight of remnants and the earlier point about remnants outnumbering active stars, but one focuses on the era's texture and the long cooling process, while the other is about numerical dominance. So I can keep both by emphasizing the quality of that distant time. I'm reconsidering whether to merge or restructure some of these points. The age of starlight itself is really just one chapter in a vastly longer cosmic story. So I could combine the stelliferous era naming with the coming twilight into a single statement that captures both the era's identity and its eventual descent into darkness. I'm settling on 20 blocks and calculating the full length more precisely, aiming for around 14,200 words by writing each block fuller, roughly 680-720 words each. I need to verify I have exactly one second-person anchor in block 10. Keep other blocks from physically addressing the listener too directly. Avoid any open-ended wonder questions as codas. And make sure there's no call to action or signature phrase. The threat neutralization happens in block 1, so that's locked in. Now I'm writing out the full text block by block. For block 15, I'm describing the far future merger with Andromeda, starting with how it appears today as a faint smudge barely wider than a fingertip at arm's length, then expanding into how it will drift toward us over billions of years, growing larger and brighter across the night sky. Continuing with block 16 on cold hydrogen, describing how it fills galaxies with a faint radio glow. Most of a galaxy's gas is cold, dark hydrogen that doesn't shine in visible light, yet it emits a steady whisper of radio waves at precise frequencies. The word count is around 610, and I'm noting that the single precise note refers to the 21 centimeter line without needing to spell out the actual wavelength. Moving into block 17 now, which focuses on how a handful of bright stars dominate a galaxy's light output. Despite billions of stars being present, only a rare few brilliant giants outshine millions of their dimmer neighbors combined. The universe will eventually cool into a dimmer age, with galaxies fading across incomprehensible timescales. Not a tragedy, but a slow seasonal shift beyond human perception. Black holes may persist as the final lights, their accretion disks glowing faintly, and the holes themselves radiating the barest energy across eons, remaining as quiet anchors long after stars have burned out. The universe age of 13.8 billion years is standard and works fine for this phase. I'm reviewing the character counts across all 20 blocks and noticing I still need to write block 14, which should cover the heaviest elements. Adding up the character counts across all the blocks to verify the total, and I'm getting around 12,530 characters, which falls short of the 13,559 minimum. I should add a few more content blocks to safely exceed the threshold and account for any conservative estimates in my character counts. Now I'm reviewing which facts I've already covered to avoid repetition. Star clusters, the Milky Way's disk structure, planetary nebulae, stellar metallicity, and dust thermal emission are all accounted for. I'm considering whether to include something about the sun's lifespan as a personal anchor, but I'm keeping second-person references minimal since I already have an anchor point elsewhere. I'm drawn to a few new angles: the simultaneous birth and death of stars across galaxies as a gentle counterbalance, and the vast light travel distances within a single galaxy as a source of quiet awe. These feel distinct from what I've already selected. I'm thinking about where to slot these 3 new blocks into the temporal descent of Part 11. They should sit among the calmer observations, rather than at the very end, where the final descent needs to land. Let me work through the revised ordering to see how they fit. I'm finishing out the remaining blocks: the dying stars, Andromeda's approach, the radio glow of cold hydrogen, how a handful of bright stars dominate the light output, and the eventual fade into darkness when black holes become the last lights. That gives me 23 blocks total with good spacing and the anchor at block 10. Let me verify the light crossing distance is accurate. The Milky Way is about 100,000 light years across, so light does take 100,000 years to traverse it. Now I'm drafting the 3 new blocks, starting with the one about light crossing the galaxy. The metaphor extends to how galaxies renew themselves. Old stars fade while new ones ignite. Maintaining a light itself takes 100,000 years just to cross our galaxy. We tend to think of light as instant, arriving the very moment we look up. But the Milky Way is so wide that a single beam, moving at the fastest speed there is, would need 100,000 years to travel from one edge to the other. A ray leaving the far rim tonight would not reach the opposite side until long after everyone now alive has been forgotten. It drifts across the disk like a slow swimmer crossing a lake with no far shore in sight. There is a strange comfort in that. Even light, the quickest thing we know of, moves patiently here. The soft band you can see arching across a dark sky is the blended glow of billions of stars. When you look toward the Milky Way on a clear night far from the city, you are not seeing a cloud or a mist. You are seeing so many stars, layered so deeply behind one another that your eye can no longer tell them apart, and they melt together into one gentle river of light. Each faint smudge is really countless suns, too far away to separate. It's like looking at a distant town at night and seeing not single windows, but one warm blur of living. All those hearths, all that quiet fire, folded into a single glow. Even as old stars fade, new ones are quietly being born. A galaxy is never truly finished. In the same slow hour that an ancient star cools and lets go of its outer layers, somewhere across the disk, a fresh one is drawing itself together out of gas and dust and beginning to shine. The two happen side by side, endlessly, an exchange with no final total. It's like a wood where a leaf loosens in one corner, just as a bud opens in another. The whole thing always the same age and always renewing. So a galaxy is less a fixed thing than a long, gentle breathing. Nothing is ever quite lost. It only changes hands. Our own galaxy makes only a star or two in a whole year. For all its size, the Milky Way is unhurried about it. Out of clouds heavy enough to build thousands of suns, it kindles just one or two new stars across an entire year. Quietly, without ceremony. There is no rush, no great flare of creation, only a steady patience measured against the slow turning of the disk. It's the pace of something that has all the time in the world and knows it. A galaxy keeps its own calendar, and by that calendar, a single human life is far too brief to notice even one page turning. A handful of bright stars outshine millions of their dimmer neighbors. When we see a galaxy's glow, we imagine countless equal points simply adding up. But most stars are small and faint, and only a rare few are enormous and brilliant. And those few pour out so much light that they nearly drown the quiet majority. A single blue giant can outshine a million small red stars combined. So the face a galaxy shows us is really the work of its loudest few. It's like a choir where a few strong voices carry over everyone else, though the soft ones far outnumber them. The dim stars are still there, patient in the background, holding most of a galaxy's true weight in silence. Every moment, the sun turns a piece of itself into light. Deep in its core, our star quietly converts millions of tons of its own substance into pure light with every passing second. And it has done so faithfully for billions of years. That warmth on a summer afternoon, the light that lets you see these very stars, is the sun gently spending itself, giving a little of its body away so that everything around it can be lit. It's like a candle that feeds the room from its own slowly shrinking wax. There is a soft generosity in it, this steady, uncomplaining gift, poured out across the whole of the sky. The combined color of all that starlight is a pale, gentle cream. I'll admit, this one still makes me smile. When astronomers gathered the light of many thousands of galaxies and averaged every color together, they half expected something dramatic. And what they found instead was a soft beige, a warm off-white, close to the color of milky coffee. Someone even gave it a fond, homely little name. All the fire of every star, all the blue giants and the glowing red embers folded together, and the universe as a whole leans toward the shade of a quiet morning. It's a reminder that the grandest sums so often settle into something wonderfully plain. Right now, the light of stars that died long ago is settling softly against your window. Some of the points we call stars finish their lives centuries or even thousands of years past. And yet their light is still traveling, still arriving, still landing gently on the glass beside where you rest. You are bathed, always, in old light, in messages sent by things that may no longer be there at all. And there is nothing to fear in that. It falls on your skin as softly as moonlight, warm and slow and already ancient. As you lie here, the distant past itself is quietly keeping you company through the dark. Some of the oldest stars are nearly as old as the universe itself. Scattered through the halo of our galaxy, drift faint, unhurried stars that have been burning for more than 13 billion years, almost since the very first light after the beginning. They formed when everything was young and made of only the simplest ingredients, and they have gone on shining patiently ever since. To hold one in a telescope is to look at something that has outlasted nearly all of cosmic history. They are like candles lit at the start of a long evening that are somehow still glowing as the night grows deep. For them, time is measured in a currency we can barely begin to imagine. This long age of starlight even has a name. We live in what astronomers call the stelliferous era, the age of stars, the stretch of cosmic time when galaxies shine and fresh suns keep being born. It began not long after the beginning, and it will carry on for an unimaginable while yet. But it is still only a chapter, a bright middle passage in a far longer story. Naming it this way feels like a small kindness, a way of saying that we are here during the lit hours, before the slow and gentle dimming. It's a quiet reminder that we were lucky enough to wake up while the lights were still on. The starlight leaving a galaxy travels outward forever. Only a tiny fraction of the light a galaxy makes ever falls upon an eye or a lens. The rest streams out into the dark in every direction, crossing emptiness that may never end, carrying the image of a galaxy that no one will ever see. It doesn't stop. It simply keeps going, gently, until the space it moves through grows too wide to hold any meaning. It's like a letter written and sent with no address on it, drifting onward in quiet faith that somewhere, sometime, it might be read. Most of the light in all the universe is exactly this, a whisper released into the open, content to travel unheard. Slowly, a galaxy's free gas is being locked away into quiet remnants. Each time a star lives and dies, a little of the galaxy's gas is tucked away forever inside a cooling cinder, a faded core that will never form a star again. Over enormous spans of time, more and more of the raw material is gently retired this way, set aside, put to rest. It's a little like a long evening where, one by one, the lamps are turned low and left, and never quite lit again. There is no sadness in it, only a slow settling. A galaxy spends its riches carefully, over ages we could never sit through. Our own sun will one day end its days as a small, cooling ember. Far in the future, so far that the number barely holds meaning, the sun will swell, then gently let go of its outer layers and settle into a quiet white core, glowing softly as it slowly cools. It won't be sudden, and it won't be frightening. It is simply the calm, natural close of a very long and generous life, an ember banked at the end of a fire that burned for billions of years. It's the way a warm room slowly cools once the day is done. By then, this night and all our nights will be an unthinkably distant memory. Far in the future, neutron stars will slowly spin down into silence. When a heavy star collapses, it can leave behind a tiny, dense heart, spinning many times each second, sweeping the sky with beams of light like a lighthouse on a lonely coast. But nothing spins forever. Over millions and then billions of years, each one loses a little of its turn, slowing, dimming, until at last it falls quiet and dark. There is no violence in it, only a gradual settling, a spinning top winding down at the end of a very long game. One by one, across the ages, these small bright hearts will ease into stillness, and their sweeping beams will finally rest. Eventually, the great black holes will be the last lights left. This may sound heavy, but there is nothing frightening waiting in it. Long after the final stars have cooled, the black holes at the centers of galaxies will remain, and around some of them, the last thin gas will still swirl, glowing faintly as it slowly falls inward. For an unthinkable stretch of time, these will be the quietest lamps in a softly darkening universe, patient anchors holding their place. It's less an ending than a hush, the way a house grows still and dim once everyone inside has gone to sleep. Even then, the universe will not be empty. It will only be resting, and even black holes in time release the faintest whisper of warmth and fade. Nothing, it turns out, is truly permanent. Not even these. Over spans of time so long that our very largest numbers lose their footing, a black hole gives off the barest trickle of energy and, unimaginably slowly, grows lighter, until in the deepest future, it gently thins away to nothing. There is no drama in it, no collapse, only the softest possible letting go. A candle guttering out after having burned for an eternity. It's a tender thought, really. Even the most patient things in all of existence are allowed, at the very last, to rest. And then the universe settles into a long, even calm. When the final light has thinned and the last warmth has spread out smoothly through the dark, the cosmos will reach a kind of quiet it has never known before, cool and even and still. This is not a disaster, only a season, the deepest part of a night far beyond any night we could ever stand inside. Everything simply comes to the same gentle temperature and rests there, together. It's the slow, even breathing of a universe that has finally, completely fallen asleep. And we are here now, awake in the warm and early hours of it all. So we've wandered a long way tonight. We drifted past galaxies that seem to have misplaced their invisible mass, and through a perfect ring with a single heart floating at its center. We passed the ones with two black holes circling slowly toward each other, the jellyfish trailing their glowing tendrils, the quiet giant drifting all alone in the dark. We watched our own galaxy leaning toward its larger neighbor, and followed the light all the way down to the last soft lamps of the deepest future. From the strangest edges of the sky, back to the pillow beneath your head. And here is the gentlest truth of all. You are not separate from any of it. The iron carried in your blood was forged in the hearts of ancient stars. The calcium in your bones, the oxygen filling your chest with every slow breath, were all made inside suns that lived and died long before the Earth existed, then scattered across the galaxy so that one day they might become you. The very atoms resting in your hands have traveled through clouds and stars and the long dark between them to arrive, at last, right here. You are the universe grown quiet enough to wonder about itself. Even now, as you rest, the galaxy keeps turning, unhurried and vast, carrying you and everyone you love in one enormous, gentle circle through the dark. The old light keeps arriving at the window. The distant stars keep shining, patient and slow. And none of it asks anything of you tonight, only that you let yourself be carried, the way the whole sky is carried, softly onward. If you happen to still be awake, you can simply let the next quiet chapter carry you gently on from here, with nothing you need to do at all. And if you'd like to drift off to more journeys like this one, softly told, you might consider subscribing, so more of these calm nights can find you, one sleepy soul at a time. Rest now. Let the stars keep their slow watch without you. You have traveled far enough for one night, and everything out there in the dark will go on turning, patient and kind, until you wake. Good night.